image and other image to visualize the systems over Amazon region. This data is available in RAM platform and in the CPTech FTP. So here I have a kind of the information of each sensor. I got the satellite images, and I have the variable cloud top brightness temperature. And I extract the features I have in image and use the B-scan. And here I got the image of the radar data. And the variable I use is reflect DBZ. For this study, I investigated the two seasons in the Amazon. The first one is IOP1, refers to the rain season. And the IOP2 is the wet season. So I applied the B-scan. I'm sorry, I have the animator hand, but it's not working. And I applied the segmentation measure to get each individual cells for the data. And I have the morphological features of each cluster in image. In the results, I obtain the size of the clusters for the daily period and the night. For IOP1 and IOP2, I have a distinct values to the less intense threshold at the 20 dBz here. For the IOP1 is the rain season. I got the largest clusters in this period. I don't see the great difference here in the satellite, but I estimation these features for each threshold and each daily cycle for each period. And the result is part of my PhD proposal. I propose a tracking algorithm and apply this. I get this result to improve the forecasting in the tracking algorithm and forecasting algorithm here. And the conclusions the result obtained is demonstrated the different features of the atmospherical systems over the study region. In during the morning period, systems have the larger areas with the less intense thresholds, principally for the radar data in 20 dBz. And the size of the clusters, it has difference between the lower intensity and the larger areas for the IOP and between the IOP1 and IOP2. In contrast, the dry season, IOP2 event is more isolated and I have more intense thresholds. So this is the reference, and thank you. I'm sorry about the English. Any question? Please, no.
I didn't think of a question. Okay, so maybe I'm doing a questions is that, so you prepare this data set of features. In your PhD, are you trying to make another kind of analysis of these features to make, I don't know, which feature is the best one if for a classification or regression problem?
Yes, I said this is the part of my PhD proposal. I have a tracking algorithm, and I'm improving the forecasting and the tracking, the extracted features using the B-scan. Here's an example of the tracking algorithm. I have the cloud clusters here individually, and I got the trajectory of each clusters. I using the B-scan to obtain more statistical information of individual cells.
Okay, thank you. Anyone else? Questions? If not, we can. Okay. Oh yeah, good one. Yeah.
Oh.
I really like the idea of the tracking algorithm, and I'm curious if it's spatial and intensity and temporal. Is it all three at the same time? How is that algorithm handling the multiple dimensions?
Yes, for the algorithm, it's not important the dimensions of the each pixels, because I'm converted to in the axis, different axis. I can get the information of the spatial sizes of the each pixels, but it's not very important
Okay.
for the tracking.
Okay.
One question.
About your question, when you are trying to track the system, we choose a thresholding to define the intensity of the minimal precipitation, you know, that you can follow this. All the structure, in the inner structure of the system, we are using to define if the system will increase or not, if its intensity will increase or not, this kind of information that's important for the forecasting. And we can have this information. We can access the algorithm which already has this model to get different levels of the radar information, and you can follow everything that it's possible with these thresholds. You know, it's the intensity, and the size. It's actually a parameter also. You can define the minimal size to track. It's not all the objects needed to this information to be followed.
Thank you. Here's my advisor.
So I'm back. Now let's call our third work called Prediction of Air Pollution Events in São Paulo based on surface meteorological variables. And who is going to present it will be André Miranda. Come here, André.
Oi, bom dia. Eu peço desculpas porque eu não sei o inglês, vou ficar no português mesmo. Bom dia, meu nome é André, eu sou aluno de Ciências Ambientais na Unifesp Diadema e hoje eu vou falar um pouco do nosso trabalho de iniciação científica. A região metropolitana de São Paulo é um lugar extremamente impactado pela poluição atmosférica, principalmente por material particulado. E a qualidade do ar pode ser influenciada por vários fatores. Alguns deles são relacionados às condições meteorológicas. E sabendo dessa relação, o nosso objetivo foi construir um modelo preditivo para a ocorrência de eventos persistentes de ultrapassagem na região metropolitana a partir de variáveis meteorológicas de superfície. E, para isso, a gente utilizou dados diários das estações de monitoramento da CETESB e do IAG, no período de 2005 a 2021. A gente procurou usar, aqui não dá para ver muito bem, mas trabalhar com as estações mais bem distribuídas por toda a região, na medida do possível. E, para a gente identificar esses eventos persistentes de ultrapassagem, ou EPUs, a gente seguiu alguns critérios a partir de alguns trabalhos anteriores. Esses critérios são eventos de ultrapassagem dos padrões recomendados pela OMS que ocorrem simultaneamente em pelo menos metade das estações que a gente andou trabalhando, e com duração mínima de 5 dias consecutivos. A partir desse conjunto de dados já trabalhados, a gente dividiu em 80% como treinamento e 20% como teste. E, como a gente queria prever a ocorrência desses eventos, usamos um modelo de regressão logística, em que 1 é a ocorrência do evento e 0 é a não ocorrência. O teste VIF e o método Stepwise foram usados para termos um melhor conjunto de variáveis preditoras que resultasse no melhor ajuste do modelo. Calculamos também a razão de chance para cada variável preditora, e a acurácia do modelo foi avaliada por uma matriz de confusão, usando o melhor ponto de corte a partir de uma curva ROC. E, como resultados, encontramos 122 EPUs, que correspondem a cerca de 15% dos nossos dados, com duração de 5 a 25 dias e maior frequência durante o inverno. No caso das variáveis meteorológicas, a gente percebeu diferentes comportamentos durante esses EPUs. Variáveis como temperatura máxima sofrem aumentos, enquanto que, para a umidade relativa, existem diminuições. Importante falar que, para esse modelo, a gente procurou usar só as variáveis preditoras significativas, isso com P menor do que 0,01, e uma variável categórica para representar as estações do ano. A nossa área sobre a curva ROC foi de 90%, com o melhor ponto de corte em 0,13, e analisando com um conjunto de testes, a nossa acurácia foi de 81%, sensibilidade de 91% e especificidade de 80%. E, olhando para essa matriz com as razões de chance, percebemos que a variável mais relevante para determinar a ocorrência desses CPUs foi a temperatura máxima, em que o aumento em 4,6 graus equivale a um aumento de 98% na chance de haver um EPU. E, por fim, concluímos que esses EPUs são satisfatoriamente previstos por variáveis meteorológicas de superfície, usando o modelo de regressão. E, como continuidade, a gente pretende desenvolver um modelo de classificação usando técnicas de machine learning, com o objetivo da gente obtermos uma regra simples de classificação que nos permita prever a ocorrência desses EPUs, se possível, em toda a região metropolitana. É isso.
Do we have questions now? Okay. Posso falar em português para você?
Pode.
Qual seria o impacto dessas CPUs? Tipo, qual é a motivação para a população?
Principalmente... o impacto maior é na saúde de pessoas já fragilizadas. Então, pessoas com problemas respiratórios, cardiovasculares, são extremamente atingidas por esse tipo de poluição, especialmente para esse evento.
Ah, certo. Muito bom. Aqui.
Oi, André, parabéns, viu? Mais uma vez. Eu sei aí que a professora Luciana tem uns dados aí de ozônio, né? Você pretende fazer também para aqueles dados de ozônio que são também da CETESB e tal?
Pretendemos, sim.
Legal.
Já estamos trabalhando. Temos alguns problemas que não vai ser a mesma coisa, os resultados vão ser diferentes, então a gente está passando pelos perrengues ainda.
Tá bom, obrigado.
I will ask the question in English, so maybe your supervisor can help. It's fortunate I was able to look at the poster in some detail. Your use of the word surface conditions, I think, misled me a little bit, because surface conditions to me, I mean, what is the surface? Is it I gather it is not the urban infrastructure, the buildings, the slope of the land, so the wind flow, because it is the temperature and rainfall in the season that mattered quite a lot. So when we talk surface, are you talking many meters into the atmosphere or what? So, does this make sense?
I'll try to.
Yeah, yeah.
Ela perguntando assim, quando você está usando essas variáveis, né, ela está falando de superfície, entendeu? Alguma coisa de superfície. O que ela está querendo saber se você está medindo isso em altitudes diferentes, né, ou se é tudo perto do solo, assim, se tem alguma relação com a altura. É mais ou menos isso.
Certo.
I think you've got that.
Ok.
Altitude.
São variáveis medidas na superfície. Os equipamentos do IAG têm essa característica, assim. Tem uma variável que a gente andou trabalhando, que é a altura da camada limite, que foi por um satélite. Foram dados de reanálise do ERA 5. Só que a gente acabou tirando ela da nossa análise porque não foi significativa.
Oh, yes, for the others. No. Yes.
Okay, I'll try to make my... So they're mostly surface data, right? So they're from meteorological stations. One is IAG, that's, I think it's here, right? Okay, but it's in São Paulo city, right? It's not here in the university city. And they tried to use reanalysis data from satellite, but they discarded, but they did not use. So when he means surface, they're talking about these stations, okay? So that's,
Okay, that's good.
I think I did it, right?
You did. That's yeah.
Go ahead.
And I really liked the relationship between the dry winters and the inverse relationship with rainfall. It was very nice that your pollution was washed out of the air. So you just have to keep the rain all the time.
We have one more question.
Parabéns, eu acho que é interessante. Vindo da epidemiologia, eu sou estudante de doutorado em epidemiologia e achei bem interessante essa aplicação desse trabalho. Poderiam pensar na possibilidade de linkar os dados com os dados, por exemplo, de mortalidade por doenças cardiovasculares. Seria bastante interessante perceber esses fenômenos nessas áreas com poluições atmosféricas. E digo isso porque na Nature e muitos artigos têm saído atualmente têm mostrado essa relação de poluição atmosférica e mortes por doenças cardiovasculares, tanto prematuras e tanto avançadas, e até doenças respiratórias. Então, seria interessante fazer linkage com a base do CIM, que é a base de mortalidade, por exemplo, e poder haver alguma possibilidade de encontrar dados bem interessantes. Tá de parabéns. Obrigado.
Obrigada.
Muito bom. Muito parabenizado, então.
Obrigado.
Thank you, everyone. That's what I call a great teamwork here. So before calling the next work, I have two things to say. The first one, all the presenters who come here later, please look to Rosa right there, because she will raise a paper telling when it's just missing 1 minute to end the presentation. Raise the paper, Rosa. Very high, that's it. So you can look to that paper while you are presenting, okay? And the next thing, all of the presenters here are being evaluated by our amazing reviewer committee, all of them. So in the end of the event, we are going to give, I think there are 3 best poster awards that actually are papers telling, oh, you are amazing, that's a great work. So maybe one of you guys may receive this amazing paper and, I don't know, maybe a cup of orange juice or something like this. So, okay. The next work would be our work number 4, but I'm gonna let this work be the final one, since the author is with some technical issues. So now I'm gonna call the work number 5. That's easier to say. The work number 5 title is Deep Learning Methodology for Predicting Socioeconomic Indicators in Vale do Ribeira using satellite images. And who is gonna present it? I In my humble opinion, she is our PARSEC queen, but that's just my opinion. So I'm gonna call her name is Isabela Melo. We've just got some technical issues with the PowerPoint file. We are just downloading the PDF file right now, so just wait a second.
So, hello everyone, good morning. Sorry for the delay, some technical problems, but it worked out now. So, my work, so I'm just putting a timer here to help. So my name is Isabela de Melo Souza. I'm a computer engineering student from the University of São Paulo, and my teacher and advisor is Professor Pedro Correia. And my work is about a deep learning methodology for predicting socioeconomic indicators in Vale do Ribeira using satellite imagery. So the motivation behind this work is that obtaining reliable socioeconomic data is still a problem, is still difficult nowadays, especially in developing countries, due to the high costs and the operational difficulties of traditional data collection efforts. More specifically, in the Brazilian context, the main census institute is known as IBGE, the Brazilian Institute of Geography and Statistics, and the data collection is usually done every 10 years. So there is a data gap of 10 years that prejudices the interpretability of the collection results at Brazil. And the main goal of this research is to fill this gap. And to do that, the idea is to develop an expensive and scalable deep learning methodology to using satellite imagery to estimate socioeconomic indicators. To do that, the base of my work was the paper of Ye et al. Ye, he combined multispectral daytime imagery and night lights imagery in a deep learning model to predict socioeconomic criteria in several regions of Africa. So the idea was to do a replication here at Brazil, and to do that, the region chosen was the Vale do Ribeira, due to its data availability and its ecological and economic importance. And I divided the methodology of the work in 4 steps. The first one was data acquisition. So for the data acquisition, the Vale do Ribeira census sectors were chosen as the model level of granularity. Then the socioeconomic variable of income was calculated using the IBGE census of 2010. And the satellite imagery was collected using the Google Earth Engine API. Second, we have feature extraction. So here the idea was to adapt a pre-trained ResNet 18 network to accept multiband satellite imagery and to do a regression instead of a classification. So the idea here is to train separately the models using multispectral daytime imagery and nightlight images to do a feature extraction. And after having this feature extraction, after training the models, combine those feature vectors in one and ran a ridge regression on top of it to obtain the values of the socioeconomic indicators. And finally, the results. So here I brought some images for us to analyze. So here we have the regression results for the Vale do Ribeira. So here you can see that the coefficients of determination of the R2 was about 0.289. So when we compare to the model, to the original paper of Ye et al., we can see that the performance was significantly smaller. And there are some possible explanations for that. The size of the data set used was way smaller. It was about 4.4% of the original data set. And also, I came to the conclusion that there is an overlapping between the images, and this overlapping may be causing problems such as overfitting, that prejudicing the value of the R2. Here also, we can drive some other secondary conclusions that I found interesting. Here you can see that the model that trained only on RGB bands performed poorly when compared to the other models, and this is an indication of the importance of using multispectral, of using satellite imagery in this prediction, in this type of task. And we can also see that when I trained the models only on multispectral daytime or in nightlight images, the value of the R2 was very similar, and was similar also to the combined model. And this is an indication that the inputs of these images, they are similar, they contain similar information. Okay, so this is the same. And I would like finally to thank you very much, my professor, Pedro Correia, Janete, that even though I was on the other side of the world, helped me to develop this project, and the PARSEC group in which this project is part of. And everyone that is here today appreciating our work. Thank you very much. So do you have any questions?
First of all, congratulations. It was
Thank you.
Really great work to see right now. In your conclusions, how did, if the model guess like for more or less HDA?
Less what?
What, the DH rating. Like, your prediction usually guessed for more or less of what it really was, like it, of the data set that you use. HDI, right? Yes.
If I remember well, about 40% was very similar, but I think the prediction when it made a mistake for more. Yes, I have a heat map of that I can send for you. I didn't bring it here, but there is a good mapping to show the differences between the original and the compared data. I think it's for more. But
So
the main
Vale do
idea is that...
Ribeira, sorry.
No, we can...
So the Vale do Ribeira was classified with a bigger HDI than you predicted. But
My predictions usually was higher than it's supposed to be. But it really, the idea here is that there is a mistake, that it's far from the original results. I think that's the main goal. If it's more or if it's less is still the idea when we gather gather imagery without overlap and we gather more images, we're gonna put these results together, regardless it's more or less than the original values.
as you told that the Yet et al. Work
Yeah, and all.
was trained only in Africa, or it's a bigger data set?
Yes, it was trained in Africa, several regions of Africa. It's way bigger than the Vale do Ribeira.
Okay, so maybe the conclusion would be that, I don't know, maybe different countries have a different way to measure HDI? Or
No, for Yen and all, he used a different metric. He used an asset wealth. So he take his research, it's a DHS, I forgot something for human social economic development, and he calculated his own index, asset wealth, and so the conclusions are different. There are two different metrics there.
okay, thank you for your patience, and again, congratulations.
Thank you very much.
Okay. Well, I got to say that I'm feeling very proud of Isabella. She has conducted his experiments very well. And of course, we know that the R square that you have obtained in your experiments, it has been due to the quantity of data. Mm-hmm. The proportion from Vale do Ribeira is very, very tiny compared to the countries that were trained in the original model. Do you think that if we try to make more data sets from Brazil to train the model, it could be increased by if you train it with more data?
Yes, I think it's going to improve. My idea now is exactly working on a methodology to gather more images and to diminish at most overlapping between the images, so you can have a really better metric, a really more real value of the R2. And I will be able to say that to you shortly, I hope, with more precision, but I'm hoping that the performance will increase.
Mm-hmm. Okay,
Yes.
thank you.
Okay, thank you. Okay, the data is not enough to train deep learning model, but also there are another problem is the size of images.
Mm-hmm.
In here, they have used a size of around 6 kilometers.
Yes.
Because I think the Brazil is not the same case. So
Yes,
the
exactly.
input,
That is the problem.
Okay, the problem of data and the size of image.
Yes, the size of the image that I gather with 30 meters pixel
Okay.
resolution
Yeah.
and the ResNet was 6.72 per 6.72, and this is too big for the Vale do Ribeira region. So
Exactly.
that is what is happening with the overlapping.
And also the input
called.
of ResNet 18.
Mm-hmm.
Thank
Yeah,
you.
exactly.
Thank you.
It's all right. I just might mention that we could ask a lot more questions of all of you, but I am aware of the time. So please, if we don't ask lots of questions of you, and the next talks, it's not because we're not interested, okay?
Okay, thank you very much.
Okay, so for our next work, that's gonna be work number 6. The work title is Solar Energy and Data Science, a prediction study for Manaus and the Amazon Basin. And I'm gonna call the guy right behind me, André Marques. So, while we are waiting for André to prepare his presentation, Marcio, our official translator, told me to tell a joke to all of you here. So, what the right eye told the left eye? Someone knows? Between us, something smells.
Good morning. Sorry for the delay. The title is quite simple. The work is also simple, straight. So it's solar energy and data science, prediction study for Manaus and Amazon basin. Okay. It happens. Right, tech questions. First, what kind of renewable energy sources may be considered for the Amazon basin? This work starts with trying to answer one of the questions of Professor Luciana Rizzo. Is around, right? Oh, she's there. I'm trying to answer one of her questions about the CO2 pollution and the implications in the Amazon basin. Because in Manaus, around Manaus, we have 11 thermal power stations emitting CO2, polluting all this stuff. Last week, they decided to change to gas. There is a natural gas source 600 kilometers south of Manaus, and there is a pipeline crossing the forest. So all this thing in my mind, and then, okay, what can we do with data science as an engineer? What about to use the local sources? Solar is one, biomass is the other one. So my work is split in two. First, solar, the easiest. Second, biomass, quite natural because you have vegetation around Manaus, in Amazon basin, but how can we use biomass to recompose the forest? Suppose a scenario, the forest will be gone. Oh, this is tragic, but it may happen. How can we recompose the forest and besides that, or altogether, to generate energy, avoiding pipelines, transmission lines, hydraulic huge stations, all this mess. We have already experienced it. So let's step on it. Okay. In this case, I start to monitor the solar incidence in the region. And I saw some strange phenomena. This is from the sky, the total solar energy coming from the sun, from satellites. I used satellites and also local stations. The local stations, they came from our defense system. And some data is not quite okay. The satellite is complete, but they not match too much. And also there is kind of this phenomena. So strange things happening. I tried to understand that, and I saw something similar in India. They have quite same behavior in terms of solar irradiation around forests. That's the boundary condition. So I tried to use some machine learning methods in order to predict the total solar irradiance in the region. I used data from 2013 to today to predict the last 4 months. So from February to May, the prediction time. And I used the random forest, all these ensemble methods, ensemble aussi, and to try to predict that. I also did a feature importance using random forest. Oh, by the way, it's just for the coincidence, random forest. And I also used it, randomized the cross-validation in order to have a kind of tool, prediction tool. I would say fair. Fair is a word, right? Here, fair. So what about to use a fair tool in this case? This is the feature engineer and feature importance. I concluded that most of the phenomena can be explained from the data. It's a data-driven project. From the intensity of temperature, it's important in the region. Explain a lot of it, and also the humidity. It explains also the phenomena. This is the results in a AWS platform. Blue is the prediction, red is the existence. So 4 months, February, March, and so on. So it's not okay at all, but it has something close here, not okay at all. I tried it last week to use also deep learning in order to improve the error, the margin. And it's not okay yet, but we can work on that. Errors, almost finishing my presentation. I split the data in week and month aggregation. In this case, for land, the best results come from the week. So we can see here the MEAA, mean absolute errors, but the good ones they came from satellite using a month aggregation with the least errors right here. And also developed a time series study using auto regression, how one variable can interfere in the other. It's across, I would say, interference. And then the errors, okay, for satellite month group, it's close with this random forest or decision trees methodology. Reference, that's it. Thanks.
Do we have questions? It's not? Okay. I was wondering in your plots from the very beginning that you saw a pattern that on the months there, and there was a change drastically on the last months. In the very beginning. Yeah. What's exactly this behavior, and why is this compared to India, and if you have checked it in other
India,
places?
yes. I had the same question. It's good to live with living questions. It's very, very, very nice to live with questions and to work to answer that. In this case, in India, it's something related with pollution. CO2, CH4 gases in the atmosphere. They have already experienced variation in the solar energy there. Okay, maybe it can explain this kind of phenomena. I'm not a solar expert yet, and then I'm trying to understand why sometimes things get deep like that. I'm trying to understand it better. If we see, if we see the country, the best part of the country for solar energy, it's in the east part. So north of our state towards the northeast. So in the Amazon basin, well, it's not so good as in the east, the western part. It's not so good in terms of solar energy as in the eastern part. So there's some phenomena here around. The best thing I have seen here in South America is in Chile. Is around here in in the mountains. It's okay.
Could it be about the ozono? What's the
Oh,
ozono?
O3?
No.
Ozone?
Ozone, yeah.
O3, right? Yeah, O3. O3, yeah, could be one of these, right? But I don't have all the correlations yet done. Yeah, I'm working on that, but I agree with you. I try to make some comparisons with similar environments. In India, they have also forest, not so dense as in the rainforest as we have in Amazon, but it's the solar incidence is quite okay. So I started to make the comparisons with this. There is something close also in Africa. Yes, I'm studying the Africa environment and how to correlate their work. You're right.
Okay, thank you.
I think your time series is non-stationary.
Yes,
that means there are seasonal and trend and random change.
No, mais ou menos. Okay. Yeah.
It will be better if you make some non-stationary decomposition before machine learning. Before make for forecasting, it should be better if you can make some decomposition method using BFAST, STL, season trend logs, wavelet. There are many methods to decompose the time series into 3 compounds: seasonal, trend, and random. And after you can use machine learning to make forecasting.
I thank your suggestion. Je vous remercie la suggestion.
Merci.
C'est très bon. But in this case, what is okay? I did, in fact, using auto-regression, I did some stationary, as you mentioned. But okay, there is some work to do. I agree.
Okay.
Thank you.
Merci, André. So, our next work will be the work number 7. And the title is Estimation of Socioeconomic Indicators Through Satellite Imagery, Analysis of Urban Areas Overlapping. And who is going to present will be? Rafael Coelho. I'm not going to tell a joke this time, but I need to tell you all you guys that we are live on YouTube. So you may watch later all of your presentations and also my moments and my joke. Okay?
Okay. So good morning, everyone. Thanks for the opportunity. Our work is estimation of socioeconomic indicators through satellite imagery, analysis of urban areas overlapping. Eu consigo pular aqui? Okay. So these are the authors. I am Rafael Araújo Coelho. So here we are working with the Nexus area. It's a really important area in Brazil. It contemplates many biomes, around 30% of the Brazilian area, and contemplates a really important economic area in Brazil. Almost all the agriculture is in that area. The Nexus area in the image is represented in green, and the red area is the entire Brazilian country. Since this is a really important area in Brazil, it requires the application of preservation and sustainable development policies, and this may be aided by monitoring environmental and socioeconomic indicators, which is the idea of our project. So our objectives, the main one is to adapt the methodology presented in Ye et al., already presented here in a previous work. This work estimates wealth index in Africa using satellite imagery with a convolutional neural network model. And the data provided is in village level. This is a really important information. The database of the images in our work are going to be collected using Google Earth Engine API. And here we are considering 3 main conditions for the model not to be biased and for us also to be able to reduce our costs regarding the data set. So the 3 conditions are that each image represents only a single type, urban or rural. These types were defined by IBGE, which is a Brazilian institute for research regarding our geopolitics, basically, our geoterritory. And in 2010, they defined there were urban and rural areas. So each image will only represent one of those. The amount of rural and urban areas must be proportional regarding the images. And finally, we must avoid the presence of the same region in more than one image or cluster. So we are trying to avoid overlap here. Then, for us to be able to meet those conditions, we must analyze what were the sizes of the images in the African study, and then compare those sizes with the Brazilian distribution of census tracts, which is the smallest granularity of our territory. So it's even smaller than municipalities. So here we have a box plot which shows that there is a big discrepancy between urban and rural census tracts. In Brazil, the census tracts that are urban are really small. Their area is smaller than 1 kilometer squared, while rural census tracts are really big. Around the median is around between 30 and 40 kilometers, and the biggest size we've seen here is around 100 kilometers squared. Therefore, considering that in the African study the images were based on the village size, the size of the clusters are 45.2 kilometers, which is between the types I've presented here. So this discrepancy makes us question which is the best size for us to use and how we are going to analyze our area. Okay. So here are our results. We have created 2 algorithms. Basically, the first step for us to understand the area was to try random sampling. We tried to get a proportion of each municipality census tract to be used as images for our data set. The result is not that good. We can see in the first image. We selected those random census tracts, and the red squares represent the image centered on those. And we can see there's a lot of overlaps. That's because since all the urban areas are really close to each other, we have a lot of overlaps. And therefore, we try to apply another algorithm, which is represented as a workflow from the first image to the last one, the second image to the last one. It's a neighboring graph algorithm. We are basically gathering all the urban sectors. They are being gathered as using a disconnected graph. This disconnected graph contains lots of connected graphs representing urban groups, which are the neighborhoods. And these urban groups in the last image, represented as yellow, we get the border of it, and we consider each cluster that can be inside of it, drawing a grid, and using IOU with a threshold of 70%, we can get the relevant clusters for us, considering the urban areas. And by doing so, we reduce the amount of images being used. Considering the entire size of the Nexus area, there would be 80,000 images, and now we only have 20,000. Therefore, we reduce the cost for us. And regarding the socioeconomic indicators we are going to use, it's going to be the mean of all the sectors that reside in the selected clusters. And these are our references. And I'd like to thank PARSEC project and Nexus project for helping us. Thank you.
Do we have questions? Okay. I also have to thank Rafael and team, Igor and Carlos. I have a question for you. What do you think are the main difference between the experiments conducted in the Africa's country compared to the Brazilian one?
In the African country, it was in village level, so the size of those territories was really they were close to each other. Here in Brazil, we have the discrepancy regarding urban areas and rural areas. So there are two extremes, and we had to do all this work to understand its distribution, because also in Africa, they are not that close to each other. There is not this overlapping problem. Here in Brazil, this was a big problem for us. That's why we had to do this work. I think this is the main differences.
Okay, and there was one point that you didn't mention that you could now have the opportunities. Which is the next steps after this work?
The next steps. This work is just the point of the iceberg for us. We are just starting to make our data set, and then with this data set we have a big work ahead. So we are going to do the training using a model similar, exactly the same first, for the use in Africa. And then we are going to, with those information we gather with the estimations, we intend to create a platform for it to be useful for any user to estimate any area in Brazil by selecting a centroid in our country, and then getting the image with the estimation. And with this we can further, maybe not in our work, but further it will be possible to understand the distribution, since we are making the discrepancy between urban and rural areas. So it will be useful for this analysis and for protected areas also, their relevancy.
Yeah, thank you.
Thank you. Thank you.
So, in our next work, all of you guys are going to find out how to locate the black-head vulture in the Amazon. So, the work number 8, it's called Evaluation of Machine Learning Models for Species Distribution Modeling in the Amazon. And who are going to present it will be Renato Miyagi.
Se funcionar direito. direita para frente, para trás, e aqui é o pointer.
Ah, boa.
Se der pane, você me avisa, a gente vai junto.
Tá. Acho que deu.
Ah, foi.
So, can I start? Okay. So, hi everyone. My name is Renato, and I represent my work entitled Evaluation of Machine Learning Models for Species Distribution Modeling in the Amazon. The work was made by me, with Felipe, and also Professor Pedro, who is here at the Politécnica School of the University of São Paulo. So first we will talk about introduction objectives, then methodology, and finally results and conclusions. So starting here with introduction, the main motivation of the project was the fact that the climate in the central region of the Amazon basin near Manaus is changing rapidly in the last decades. This is due to the growing of the city of Manaus that is located in its center. So this growing anthropic action has an effects on local dynamics such as the distribution of species and fauna. So therefore, it's necessary to have a large volume of data regarding the environmental conditions of this area to understand better these relationships. And therefore, between the years of 2014 and 15, the Go Amazon project, or Green Ocean Amazon, was conducted, and the project aimed to obtain a large volume of data of this area, not only through aircrafts, but also with field locations and field towers. So the analysis that can be used to understand better these relationships between the environmental conditions and the occurrence of species in the Amazon is called the Species Distribution Modeling, or SDM. And for this application, a lot of techniques can be used, and one of the main and that is we can say a trend in the literature to use artificial intelligence and machine learning models for these applications. And the main objective of this project was to evaluate machine learning classifiers for this species distribution modeling process with a study case in the Amazon basin region. So now, methodology. The methodology that we use for the project is composed of 5 main steps, and the first one is the construction of the scientific hypothesis, which in this case was that the variation in the concentration of aerosols due to the anthropic action has an influence on the distribution of species in the region of Manaus and Manacapuru in the Amazon. Then, in the data analysis step, we needed to have a bioclimatic data set composed not only by the environmental variables, but also the species distribution variables. And combining both these data sets with a joint operation, we could have the bioclimatic data set for which we could use and perform the species distribution modeling process. The species that we selected was the black vulture, as Philippe said. That was the species with the highest frequency of occurrence and was not so sparse, spatially speaking. And then we needed to select the features that would be used for the models to predict the probability of occurrence. Then in the modeling step, we use 2 models. The first one, the maximum entropy model, which is the most common in the literature for this application, but we also tried and evaluated a decision tree classifier, which is a simple machine learning technique only to see its feasibility for this project. And then we did the prediction and validation of the scientific hypothesis. And here, talking a little bit about the results that we got, we evaluated both models not only through their classification and performance metrics, such as accuracy, recall, precision, and the area under the receiver operation curve, but also through their ability to explain what the model fitted and why it made such a prediction, and that is really important for the final user or the colleges to understand the outputs of the model. So here in table 1, we can see some classification metrics for both models, and we can see that for accuracy, for instance, the accuracy was of 99% for the decision tree classifier, and was a little bit higher than the maximum entropy, which is the baseline reference here. For recall, which is the most important metric when we have an imbalance problem in which the minority class is way smaller than the majority class, we can see that the maximum entropy, which is the baseline, was much better than the machine learning model. And for the area under the curve, we can see that both models performed well. And here we also have some images, some figures that can help the ecologists, the final user, to understand what the model predicted. And so in conclusion, we were able to conduct a machine learning, to conduct a species distribution modeling experiment with a machine learning classifier and evaluate the scientific hypothesis. That's it. Thank you.
Do we have questions? Okay. Renato, well, I saw your presentations some weeks ago, and I was wondering which is the contributions you made it after the works from Pinaya, because you mentioned a lot of the work of Pinaya. So which are the contributions that you advance with this work?
Okay, here we can go back some steps. Well, in the work of Pinaya, different than the work of Pinaya here, we used a data set that was composed not only by geographic variables such as altitude or vegetation, but here we used also variables that, for instance, pollutants, and we can say it's a different, it's almost a new analysis that we did here. It's not common in the literature to find works that used this kind of variables for species distribution modeling process. So I guess maybe the variables is one of the main difference that we have from the work of Pinaya. Also, when we talk about the data pre-analysis step, we can say that we tried different techniques for the feature selection step. So we not only tried to use the principal component analysis, but also we use correlation matrix, also another techniques. And also in the work of Pinaya, he just used the maximum entropy model, which is the baseline. And here we tried to evaluate how a machine learning classifier could perform in this kind of task.
Mustn't prolong it, but if you move on a couple of slides, your results, which showed the graphics that an ecologist would like to see. This one on the left, yeah, that one. I was about to say, please, on the poster, make it bigger. Same thing here. So this is the sort of thing we're seeing with some of these machine neural network models with more variables, but you've presented it like a graphic, I think, there. Is that correct?
Yeah.
Yeah, so they're very interesting. So these are these extra variables that you've put in, I think. Is that correct?
Yeah.
Yeah, they're the extra variables. Don't undersell them. That's really interesting. The other thing that, just as a commentary, it's a good species to choose because there is very little error in identification. By the person who's collecting the data. So you've removed a lot of that sort of variation by choosing a black vulture. So if you want to add some more goodies on the other end, this stuff, it's a good example. And then you can move kind of to some other species later. So yeah, thank you.
Okay, thank you.
Yes.
I'll do a quick follow-up since I'm a species distribution modeler myself and I like to think about these things a lot. I think it is really novel, including the pollution and whatnot, but I'm curious on the, I guess the spatial accuracy, the spatial representation of some of those data sets, and as well as temporal, because in typical species distribution, we're looking at vegetation, which is a long temporal data set, right? Tree typically stays there for 100 years. Pollution is a bit more on the minute to hour scale, and so I'm curious in your thoughts on how to reconcile some of that difference in the data types to avoid overfitting, pseudo-replication, all those kinds of things.
Yeah, that was a problem that we had because we had these measurements of pollutants mainly during only a period in which the aircraft performed the flights. So what we did here was to take a mean. So it's basically the mean value of the variable in the latitude and longitude in the IOP, that is the operation. And there was two operations that were performed, one in the dry season and the other in the wet season. So basically, this the values that we use are the mean values for each station, in and not only the dry station but also the wet station. And for this date range between the dry station and wet station in 2014 and 15, we also selected the species that were observed during this daytime and in this spatial range.
So we have 4 more works to finish this session. I'm gonna jump the work number 9. So now I'm gonna call the work number 10, that it's called Spatial Sensitivity of Complex Network Communities in the Amazon Basin in relation to the minimum linkage value. That's a very long title. And who is gonna present it will be... É o César que vai apresentar? Cadê o César? É você, César, que vai apresentar? Cadê aqui? César Arturo!
Hi everybody. Good morning. I try the best for explain my work. With title is Spatial Sensitivity of Complex Network Communities in the Amazon Basin in relation to the minimum link value. Amazon Basin is the largest rainforest in the world. For different reasons, this region is so important. For example, Amazon Basin could modulate the regional and world climate. And other important system in South America is the South American monsoon system. The South American monsoon system is associated with change in directional of winds and present the rainfall. And in this work, the main objective is try to understand the related into South American monsoon system in Amazon Basin. For this purpose, we use the data from GPM, the product emerging final precipitation level 3, with a spatial resolution in 0.5 and specific for daily accumulated. The period is December 2000 to February 2021, and the season in specific is the summer. We use summer because in summer the South American monsoon system present the more stronger presence. And this is the link for the free data, or for download the data. Well, a complex network is based in graph theory. In the figure is show a very simple graph with 3 nodes. When graph is composed for a node and the link into 2 nodes, name it edge or link. For this application, we use a node, or we define a node as a rainfall time series, and the edge into a pair of nodes is the Spearman's rank correlations. When we, or for make the network, we compute the Spearman rank correlation into all possible pairs of nodes. And when we have this matrix, we use only values of correlation greater than 0.6. This is the threshold. With this threshold, we make this network. And for try to the sensibility or explain the sensibility for this network, we use three others threshold values. This is the figure shows the results for the 4 networks. In the top left is the network with the minimum threshold, 0.6, and in the right bottom is the maximum threshold, 0.78. Well, for the figure in the top left, we have we found 6 graders communities. A community is a region where their nodes are have many density related to connectivities. For example, the nodes are into community blue are more connective in related or the whole network. It's easy to show that when the threshold is higher, the network has more number of communities, but with a lower area. This is okay. This explanation is because when we use a major minimum value, the network will be broken. And for these results, the more associated spatial pattern is for the result to 0.74. Finally, the complex network is a very powerful method, but in this case, I use this method only for clustering technique. But the complex network provides much more information, important or key information about the system. For example, how is transport the information, or where are the more important areas or nodes in this network. For low AMC values, the network presents generalized communities, large communities, and for high values is the opposite, very present small communities, or in other words, the network is broken. This is the list of reference, and that's it. Thanks.
Very good presentation. I just want to know, why did you choose 0.6 for the MCV?
Yes.
Is it a lower number?
When we have all possible connections in Spearman, for Spearman, we use only the 2% of more greater connections. Why 2%? Because I'm based in the literature in other 2%, only 2%, the all possible connections. Is this normally value used in bibliography, in other articles, in case works. And with 2% of all possible connection is 0.6.
Thanks.
Thanks.
I have one more question for you. Which represents the nodes from your network? How was modeling? I couldn't check which are the nodes, what represents the connections between nodes.
In this case, I use Spearman correlation. This represents if the change into 2 series of time. Okay. And for this reason, one community shows regions where the variation, or I don't know how do you say, regions where the rainfall is very similar in the point of view for example, I don't know. Sorry.
So maybe it's the correlation between time series, and then you get a connection between those according to this correlation. So you connect. Okay, so you can have plenty networks modeling.
Mm-hmm.
Okay. Yeah, and that's very nice. And maybe.
Oh, sorry. One community represents points or time series with behavior similar. In this case.
And did you get, for instance, what about the isolated nodes? Because you here you're getting the giant component.
Yes, because I have a limit for what is a community. For this case, one community is defined for with a minimum of 30 nodes. For this case, we have areas without communities. Maybe these areas have communities so little, or maybe it's a community composed for one node, and one node is not a community.
Okay, thank you.
Thanks.
Okay, thank you.
So, for our next work, curiously, the next work has the shortest title, but the biggest number of authors. So I guess the space was limited. I don't know. So the work title is Characterization of Deforestation Patterns in the Amazon. And who is going to present it will be our official translator, Márcio Teixeira.
Felipe. Você está em PowerPoint, eu acho que ele tem que estar em PDF. Tenta botar no presentation. Aqui. Presentation aqui. Foi. Okay. Hello. So this is short title, a lot of authors, but that's it. Few superstars like Jeanette, Professor Pedro, Felipe. That's us. So I have just 5 minutes, so I'll try to speak everything in 1 minute. So you can get the whole idea, and if you want to run away and do your business, you can go. So what we are going to do here is identify deforestation patterns using statistical and machine learning techniques. This is the goal of our job, right? How? We use detailed land use images from map biomas, okay? This is an open platform that they map the biomes in Brazil and some place of the world, right? And that means data. That's a lot of data that we want to use, right? The outputs, we want to predict deforestation patterns and the rates of deforestation. So we want to see if a place is going to be deforested and how it will be going to deforest and how fast is going to be deforested. These are our goals. And applications. One of the applications is to input this in climate models. For example, the collective Earth system model. This is one thing that my supervisor, that's Professor Luis Machado, is doing, right? It will start a cooperation with China. So that's it. No, let's go on more detail. Okay, this is our lab, right? So we select 2 regions in Amazon. And I should say before that this is a work in progress, right? So you have some partial results. We are working on that, so we have less than a month here of work. But I want to share with you because it's nice to see if we're going in the right direction or not, right? So we have a north region of interest with incipient deforestation. So we don't have many deforested areas, which are marked here in yellow, right? And we have the south region of interest with large deforested area. So this area is pretty damaged yet, so it's almost irreversible, okay? So we wanna, so this is our baseline, and this is where we don't want to get, okay? So how are we doing this? We select an year and an area. This is the South Roy, for example. We binarize the image, so we get everything that's forest, we turn in 1, and everything that's not forest, we turn in 0, okay? Then we label the deforest areas, so each one of these areas has a unique label so that we can follow its evolution along the years. And then we calculate some metrics on each of these areas. So like flatness is, if you draw an ellipsis in the pixels, right? It's how it goes like American football ball, or it goes closer to a circle. It's oblate or prolate. It's the technical name of this, right? Then we have the, oh, sorry, not here. We have the compactness. Compactness is a reason between area and the perimeter. So it gets if it has a lot of spikes, basically, is that, right? And another metrics. And in the end, we want to get some time series and features for our model. So what do we got so far? The question, and this is an open question really, is that a path for deforestation? Because what we identified here when we plot flatness, that's how it's elongating, and the compactness in the y-axis, we see 3 distinct regions. This is the north region of interest with less deforestation, and here are the most deforested areas, south, and here is also the south. But from a time perspective, it comes from here to here, okay? So that's one of our questions. So is this a path to deforestation? So do we go from here to here? We don't know. We're still trying to answer that. And the fishbone pattern, the one that you see in satellite images, you can easily identify for the average flatness. So as if it has an average flatness, bigger average flatness, it shows the fishbone pattern. This is the only one that we studied. There are many others that we are interested. So what we have to do? A lot, right? So we want to predict how the things are going to evolve, north and south Roy. This is 186, and this is how it's in now. So we don't want this to go to this, right? And what we have to do, we have a lot to aggregate to this model, right? So we have, we stood land use, so we can put another layers there. In data science, you call this data frame. We physicists, we call this tensor. But that's what we're going to do. We're adding layers and adding more complexity to the model. Thank you very much. This is my contact. I am with the Atmospheric Physics Lab and Research Center for Greenhouse Gas Innovation. Thank you very much.
Do we have questions? Okay, I don't know if I can make a question because I'm part of us at the work.
No, you're not.
Okay. Yeah, conflict of interest.
No, okay.
No, then
just kidding.
No, it's okay. What do you think is the, because this is a nice problem where visually you can see the fish bones patterns that are also can be measurable with these metrics, like as you have mentioned, these the metrics. Which other metrics, according in image analysis, could be explored, or if you have think of other metrics, or I mean image analysis techniques?
Yes, we have a few metrics. There is another one that I did not put there, but it's in our study. It's in my computer there if you want to see. It's called circularity. So we have, it's almost the opposite of the flatness. So you get if the thing is circular or not. So, and you have plenty of them. So the interesting thing here is when we found this correlation or these clusters, this caught our eye, and they said, well, we have something here. So we have something here that we can put in a deep learning model. There's something here that we can put in a classification model. There's something here that we can put in a linear regression model. So we start with that, but that does not exclude that we want to explore other options.
Thank you. So, okay, I think we have done, yeah. Thank you, Marcio.
Okay.
Just 2 more works, guys. Let's keep going. So, the work number 12, it's called Neural Network Model for Classification of Net CO2 Fluxes Scenarios in Tapajós Forest in Amazon. And who is going to present it will be Lucas Bauer. Quero ver os slides.
Isso aí. Você passa pra mim? Não. Ó, tem um pointer aqui, se você quiser. Tem um pointer aqui pra frente e pra trás. Tá bom, obrigado. Depois você põe na tua. Okay. Good morning or good afternoon. Thank you so much for all of you being here. I am really nervous and I will try my best. Let me introduce myself. I am Lucas. I am a master degree student from the environmental analysis program from Federal University of São Paulo. And here I will present to you our work. It's about a neural network classification model for predictive scenarios of carbon exchange in a small region in Amazon. Okay, so let's go. So what was the motivation of this study? The carbon exchange in the Amazon are really complex. The relationship between the CO2 fluxes with the environmental factors or environmental variables are non-linear and are dependent from some factors, some main factors such as the variability, such as temperature, water available, nutrients, climatic teleconnections such as La Niña, El Niño, or another meteorological anomaly, air pollution, the seasonality, the presence of the aerosols or clouds, and more. No? But how can we know if the Amazon is acting as a source or as a sink of carbon, or a source as a sink of CO2? No? So we use the network system exchange. It's like a balance measure. So this variable represents for us with positive values that our site is acting a source of carbon. Is basically the difference from two great fluxes. One, the activity, the photosynthetic activity that remove the CO2, and the respiration process that emit CO2 to the atmosphere. So, and one way to promote a better understanding about this complex problem is applying data science strategies. Okay. So the main objective of our study was to assess the influence of integrated data set of environmental variables using an artificial neural network to identify 3 possible scenarios. One of neutrality, other of source, and at least one scenario of sink. So the data set used are all available. One data set the principle data set is a data set based in edge covariance measures from the large-scale biosphere-atmosphere experiment, and we integrated two more products. One from the satellite MODES, aerosol optical depth, and one more from NOAA satellite. I'm sorry. So, I'm sorry. To develop the algorithm, we made some process. We prepared the data, we removed all the missing data, and we made a simple transformation of the data. So basically, we use a scalar function, a standard scalar, but basically we just subtracted from the value of the observations the mean of the population, and we divided by the standard deviation. After that, for the target variable, we made a simple preparation. We defined the three scenarios. For values higher than 0.5, we define as the source. For values between minus 0.5, negative 0.5, and positive 0.5 as neutral scenario, and for values, lower values than minus 0.5, we define as a source scenario. As a result, from the neural network, we didn't had a great performance from the model. We had a better, I'm sorry. We had better predictions for sync scenarios and two source scenarios. But the thing more interesting understood, although the model wasn't so good, is that it was possible to compute the feature importance using a technique based on the game theory, based on the shape values. And with the main variables, with the more impactful the models, we could explorate the data, the original data, selecting the main variables and plotting some graphs I'm sorry, as this example is a parallel coordinate graph, which we decided which variable we use based on the main impacts on the model, and we select the range of values to see the conditions or the patterns that can lead the forest act as a sinks neutral or a source of carbon to the atmosphere. And that's all. Thank you very much.
Do we have questions? If not, I was wondering about if you could explain us a little bit about this shape method to explore the features. In which features do you think are the ones that had obtained better information so that you can make machine learning after that?
Okay, so I'm sorry, it's just to, I'm sorry, can you repeat? It's just to...
for instance, the importance of this, because I cannot read, but what do you think of these best features that the method from SHAP has obtained? What do you think they are meaning? Their meanings?
Okay, great question. Thank you. So there are some things that I'm working to get a better understanding. But for example, for sync scenarios with this bear with colored with the pink color. So for sync scenarios, for example, we see that for the national forest of Tapajós, we see the force acting as a sink related with higher values of the radiation, incident radiation of the top of the atmosphere. These values are associated with the season in the region, and these values are typically from the end of the dry season, between the end of September and October, and also with the month February and March. So with this feature importance in exploring the data, using these features, we can identify that for the period of the 2002 and 2006, we have that the force act as a sink. How can I say? Oh, I forgot. But principally in the rainy seasons. So, but it's not just that. No? So, for example, this one is the sensible heat flux is associated for the energy used for changing the temperature of the atmosphere, and the latent heat flux, this one, is associated with the energy used for evapotranspiration process, for example, which is related with the photosynthesis, for example. And the last one is the leaf area index. There is something very interesting here too, because for example, when we observe the higher leaf area index, which happens in the dry seasons, we not necessarily see a great photosynthesis activity. There is a delay. There is some papers that report that this time is about 40 days. In our data, we find a delay about 169 days of delay, for example. So basically, what it means, the results, that is the carbon exchange can be related with the seasonality and some, how can I say? Sorry. And also with some variables which are related with the available, with the water available in the area, such as these two.
Okay, great, Lucas. Maybe you can explore another kind of plot so that we can make more understandable of this picture, maybe on a special plot or something. I don't know. Maybe it could help. Okay, thank you.
Thank you.
There's a quick one on this one that picks up back to the turkey. No, not the turkey, the vulture. Leaf area index of itself, and this is important for machine learning, I think, when you're getting into someone else's domain. Leaf area index is a notoriously error-rich variable, okay? Because there's a lot of self-shading and it's not a very easy variable to measure reliably. So just be aware of that when you're in some of these circumstances. So for example, the accuracy of identification that you can get out of, for a vulture, and I've seen them, and a capybara, and I've seen them, you know, and you go, yes, I know what this is, versus a little tiny brown bird, is very similar to the sort of accuracy of variation of some of these variables. So you might like to think upon that when building some of the predictions. Because if they're inherently variable to start with, you've got a little bit more difficulty. And looking at that split is quite interesting. I did mention to you earlier, possibly something that might help is to do something in a very different vegetation type that might help. The compare and contrast can often be useful in pulling this out. But yeah, there are plenty of papers on this, so it's not that you haven't got a rich resource to draw upon. So take my comments with a little, go and do some research and just see how confident people are about that LAI.
Thank you very much.
Yes.
Okay, thank you, Lucas. Well, I think we have finished, okay? There is one more, yeah. Thank you, Lucas.
Thank you.
Well, since I am one of the authors from Lucas' work, I can tell you guys that this figure is actually a tribute to Halloween that's going to happen in the end of the month. So it's a very nice plot, but it's kind of scary, spooky, I mean. So for our last work, the work number 4, the title of the work is Systems Architecture for Analysis and Visualization of Atmosphere Data. And who's going to present it will be Ricardo Oliveira. Just to clarify, this is the work number 4, okay?
Calling Felipe for another joke session. Extremamente importante. Você vai me dizendo, eu vou ver como é que eu estou de coordenação motor. Tá bom? Fica tranquilo. Beleza. Vamos lá. Vamos juntos. Okay, never mind. Let's just get started. Well, since I'm the last one, I have 100% of accuracy that I'm the only one who's talking about systems architecture. All right, so before we get started, some disclaimer. I don't want to be obvious, but my apologies if I look like I'm nervous. But, you know, I had some theater classes when I was young, and, well, I'll pretend I'm an actor here, even though I practiced my speech in like 10 minutes ago. Well, let's get real. Let's think about the biggest challenges of any researcher that needs to run an experiment, all right? Let's think about some of those challenges. You can think of like one of these challenges could be having a good idea for experiment, right? I don't believe that's the problem. Why? I can see in your faces that you have lots of ideas flowing in your brains, so I don't believe that's the problem. Maybe you can think that you need time. Well, time is all we need, right? Probably we don't know how to use our time in an effective manner, but that's another subject. Okay, let's think of the two biggest challenges. I do believe it's the biggest challenges for researchers. One, maybe Marcia already said, it's data, right? And when talking about data, we can think about data availability, data size. You need, maybe that's the part where we can think about time, but the pre-process effort you need to handle over raw data in order to have it fits to your experiments, right? That's one of the biggest challenges maybe a researcher will have when running experiments, right? Another one could be, let's just think that you have your experiment done, you want to reproduce, like give to other researchers to reproduce to see if your results are good, if the conclusions are the same. So how to recreate that experiment using the same data you used in order to reproduce the experiment, right? So those are the big challenges I believe researchers have when running experiments. Next slide, please. Okay, so first things first, data. Most of researchers only have its own laptop, its own hardware to run your experiments. And when talking about data, it can be atmospheric, climatic, whatever is the kind of data. You can think of data sets that could be like megabytes or maybe gigabytes, tens of gigabytes, hundreds of gigabytes, or maybe terabytes, right? Maybe if you think about gigabytes, it can be too much to handle in very simple hardware. Let's think that researchers only have available a laptop with a few CPU cores, a few memory, so it's not possible to have that data pre-processed in an efficient manner, right? Next slide, please. Well, one of the situations we had is when we got an experiment when we want to correlate biodiversity data with the presence of species in the Amazon basin with climatic and atmospheric data. We're not talking about too much data set size, right? It's about 5 to 6 gigabytes of data. But because they have like different time resolutions, we need to pre-process the data in order to have those summarizations on a daily basis. This effort took in a gaming laptop, which has the best hardware as possible. We took like 30 hours to pre-process that data, right? Okay, given that, we designed an architecture that could be useful for handling the pre-process time for experiments, as well as having an environment to reproduce those experiments. Next slide, please. All right. We call this architecture BioClimavis, which we designed to work on any cloud provider as possible. So we are representing that cloud provider as the elastic provisioning platform down here. Okay, with both hands to point to the right thing. Okay. And with that, on top of this elastic platform, you can get all of your data sets and pre-processed in a distributed processing framework. So then, when you have those data pre-processed, you can start in a temporary NoSQL storage. With that, you have the data all set for your experiments. What is missing? The server controller, the notebooks, where you can run experiments on top of that data. Okay, a little bit of technical terms here. The Elastic Provisioning platform we're using is based on the Kubernetes technology, where you can spin up the NoSQL storage like the Cassandra, because it's closer to a tabular format for researchers, as well as you can design the NoSQL storage, the tables for your experiment. The distributed processing framework is based on the Apache Spark framework. Probably some of you already heard about it. And the notebook server controller, I believe it will be like, it will be an unanimity that people knows that it's Jupyter Hub tool, right? With all these components, we designed that architecture to run on top of this cloud provider platform. Next slide, please. Okay, so these are the references. Next slide. Volta uma, por favor. Volta. Mais uma. Okay. All right. Próximo slide. Não próximo. Próximo mesmo.
Esse aqui é o próximo.
Isso. Próximo. What a shame, I'm an IT guy. Okay. Well, okay, anyways, I would say I could finish my presentation with like a good demo as a preliminary results, but I don't want to hurt the demo of the gods of demo. But I have a working environment in my laptop. If anyone is interested, how does that work? I'll be glad to show something running on that platform. All right? That's it. Thank you so much.
Do we have questions? Yes.
Hey, Ricardo. Congratulations for your presentation, which was very good. Can you go back to the architecture slide, please? I'm trying to understand, you said you have multiple data types incoming, like CSVs or databases or other types of data coming from the web. So first you are data processing, and then you are syncing the data to NoSQL storage, which is Cassandra. Is that right? How would you handle the different types of data? For example, I think you may need different strategies of processing this data to insert in Cassandra, because they are column family, right? And you would have to at least know and read different types of file formats, and then build a strategy to insert in Cassandra. How would you handle these different strategies? Would you implement it one by one? For example, I have a database, which is the ATO data, for example. Would you understand the data in the ATO data and then build a strategy to insert in Cassandra, or would you implement a simple transformer that works for any kind of data? Do you know what I mean?
Right, okay. So our initial design for BioClimavis is first to give users a way to pre-process a huge amount of data without having any problems with computing resources, okay? As for dealing with different data types, this could be another subject that probably for the first phase, it won't be part of the design, the system architecture context, okay? Why? Are there ways to handle different data types without any development effort? I believe there is. I was looking at some strategies to do something like this, but it might need like some extensions to that system architecture to make that work. Yeah, that's it.
Okay. I have to just make a quick comment. I think, Ricardo, you have been very humbled for your work. And it's luckily you have been the last one to present because you are concatenating all of the works that has made working with data, atmospheric data, remote sensing imagery, and none of them couldn't make their works if they don't have an infrastructure. So you're working, it's a platform that allows for any kind of researchers to make their own experiments by using your technology. Yeah. And they can increase, decrease. It's an elastic platform that could allow them to make reproducing experiments and whatever.
Yeah, definitely. This is maybe something that I can say I'm kind of proud of that work because I could see that all of you are working with some machine learning models, and probably data is the biggest blocker for you to move forward with your experiments. My work could be considered as a foundational work for enable all of you to work on your experiments without any extra effort or any technical debt for running your experiments.
Okay. Thanks, Dave. Thanks. So we are closing now. I think on the afternoon we have the premiations. Yes, Alison, please.
And I beg Shelley too, if she would like to speak as leaders of the PARSEC project. We'd like to and relay a message that perhaps Macho has discovered from a number of the people who are watching on YouTube, that the work that you've been doing via the presentations, because the people on YouTube haven't seen your posters yet, has been terribly impressive. And I've got messages from a couple of people to say, please, Alison, please say how much we are impressed with the work that Pedro, Janeth, and the team have been doing to sponsor this and push ahead this sort of work. It's been very impressive indeed. So congratulations to all of you, and we're very privileged to have seen what you've been doing and to continue. And one of the things that I might mention, and we will hopefully be on YouTube so people can see and look, is that the posters themselves are up on ESALQ, the AGU preprint service, thanks to Shelley. And so the people who are on YouTube can catch up with them. So that link, I think, is at the bottom of the website entry, the website URL, the page for the agenda. So please have a look at that. And there, right at the bottom there, if we scroll down to the bottom of this page, please. Can we scroll down? There is a link to where you can see the digital versions of the posters that you've heard about today. So thank you. I think that's about it. Yes. We might have to propose the next time.
Yes. Yeah, we are going to provide these links to the YouTube. Thank you.
It was a pleasure to be your host today, and so let's lunch.
Pessoal, in the afternoon we are going back 30 minutes later, so we finish later. So 2 and 13, it's the next time, okay? 30 minutes we are just making for lunch, okay?
We might make that. Yes, okay, that's good, because we can make up the time.
application, it will be used for another application. So for pandemic effects on tourism. Yeah. And also the challenge. Hello everybody. Before start, I would thanks Alison. Yeah, Alison is the PI of PARSEC and also. Non, je vais finir. So that is the main contribution of this project is to use the satellite images, the combination between satellite image and remote sensing data in order to estimate poverty for many regions. So for that's here for the data science context. Now for our context of PARSEC, in order to evaluate framework able to estimate
ajudar, por favor? Aqui todos colocaram... Aqui esse aqui é o computador, não sei de quem que é o do Felipe.
Esse computador é o que vai na tela.
Isso, então eu preciso copiar aqui todos aqueles vídeos, só não sei onde está. Ele tem na segunda.
Troca a foto.
Não, não vou trocar minha foto. Mas supostamente ele tem um link. Só que eu tô, Felipe. Just one moment.
Okay.
Because this is not my computer.
Olá, tudo bem?
Boa tarde. Você também vai apresentar?
Não. Só vindo da aqui. Eu vou ficar lá em cima. Acho que hoje conecta. Ali, David will connect today or not? Are you expecting David to connect?
No, just me.
Just you.
Just me. We present
Que lição aí, Bia?
It will be an hour, and I think it will be because we have 30 minutes, so that's okay for me. Janet, you can try this if it will be work. It will be useful for us.
Eu acho que eu vou esperar lá.
Todo se moveu meia hora porque saíram tarde para mostrar aqui. Então, primeiro o Ali, depois quando a Santi tem vídeo, depois o professor, não sei se ele coloquei a Alisson, tá. E daí na tarde sou eu, professor de novo. Não, esse sou eu. Nossa, eu já ah, então esse aqui é o meu. E na tarde professor, de novo professor tá ali.
Então de fora vem o como só.
Tá.
Tá bom.
Eu vou compartilhar aqui o meu drive. Isso. Tá.
For your master, you try to use the street view in Valde Ribeira case or?
Yes.
Okay.
So I'm using Valde Ribeira as the case. So we had that one that we made.
For example, now you have transfer learning for Valde Ribeira. Okay. For you, we want also to add this street view information.
Yes, and then I want to compare the three models actually. The model only Street View, only Google Maps, static maps,
And
only
with the Landsat in Nightlight maybe.
only and then combined.
Combine, yeah.
And then combined. That's what I'm.
Because it's not the same information for each
Yes.
sensor, it will be
That's it.
complementary
Yes.
information.
Yes, and that's what I'm expecting to have. With this complementary, I expect to improve results, and that's my expectation, which I didn't achieve yet. So
You found the street view about the Valde Ribeira?
yes, we have already all Street View. We have the model from Street View. I have all the images from static maps, and I create.
How your problem now?
My problem is in the model. I trained the first. I have this picture vector, 4096 features. But now when I'm training with then I'm choosing, for example, the income variable. I have 4 variables that I'm testing: income, literacy, longevity, and population. And I'm training, for example, for income. But when I go to prediction with this picture map, the results are not good. That's where I am right now.
Next week, maybe I can show you.
Next weekend,
Yeah.
just for
2 weeks.
Yeah.
It would be a good moment for us to sit down and discuss.
But please take it. Déjame ayudar aquí pensar. Estoy descarregando. Estos son todos los archivos que tengo aquí. Solo preciso confirmar el horario y la secuencia, ¿no?
Primeiro ano.
Primero año.
Ah, tá aqui. Esse é o chave.
E eu acho que o Jeffrey não vai conectar, né? Então, fica mais conversa. Alô? Alô? Gostando, tudo bom? Maravilha. Tudo bem. Tudo bem, gente. Então, o Brasil hoje está por perto, está bem enrolado. I think it's the best solution to present here.
Yeah.
You have.
By Zoom?
Yeah. You have presentation? Or?
Yes, this is one, right? It's okay.
Okay. Oh, you have download?
Yeah, download it.
No, I hope that will not charge. Can you put okay, yes. Yeah. Okay. It's okay. Okay.
Aqui te falta future.
You can delay it the conclusion. I think I hope I will finish with the hands on. You can copy hands on. I will, yeah. Thank you. Hands on. The best solution is it will be should I finish 30 minutes. You should finish after this. Yesterday, Professor Marcelo said the first idea is to take us to Utrecht, and when you go, she
he proposed to make to drink something, and after drinking something, he proposed to eat, and after to eat to shopping. You have returned at 10 p.m. Hmm?
You have plenty activities for today.
Who were planning this? Pedro? Okay.
Oh my god, I can't use this computer.
Did you have the presentation of Alison or no? Just me and you? And video of that
Everything what is in the drive, I am downloading. I don't know any other things. But
I think Alison not yet, yeah.
Yeah, let me check. Estou sofrendo aqui com o Windows.
Then after Bart Rivera, I wanted to change the okay, can you some proposal close to the university and save some hotel here.
No, I didn't get it. After Valdo Ribeiro, you want to change hotels?
Yeah. Because it's complete.
No, sure. I will check. I have one here, but it's not good. It's a bad hotel.
Okay.
But I will search a little bit more for
Okay.
good
Can you
hotels.
just send me by the
Sure, of course.
Okay. Before Friday, it will be because Sunday it will after my and I think the connection is bad in Bulgaria.
Probably.
Yeah. I should make a reservation.
No, I will.
Yeah.
I will take
Yeah.
it. We chose that one that you are staying right now because it's a good one.
A good one and very expensive. Okay.
It's expensive and close.
And close, exactly. Yeah. And now it will be complicated.
Yes.
So, yeah. It's very good.
I have some people who come outside São Paulo that goes to the university. They take the one that I'm in my head right now.
Okay.
It's one that's really cheap, but it's really bad too.
Okay.
I need to study options. I need to study other options that it's in between them.
Okay.
And you think only you are going to stay?
Just me, yeah.
The rest of the people on PARSEC team are leaving?
Someday, maximum Monday. I think Alison Monday. No, Alison 2 October. I think Sunday.
2 of October or
2 October.
October 2nd?
Second, yeah.
No, 2nd was Sunday, last Sunday.
Wait. Yeah.
12.
Maybe. I think 12, yeah. 11 and 12, yeah.
Yes.
11, I think Alison is the last.
The last one.
The last. 12, I think.
I don't have the Alison's.
She.
Economic
Yeah.
assessment.
She working now.
So
Yeah. She didn't finish it.
Okay, so after that, Professor Pedro, then we don't have slides. So maybe an 11.
Okay.
Professor Pedro have presentation today?
Yes.
Okay.
And I think he's coming twice in 2 moments. I'm gonna go upstairs to stay there. I'm all the technical.
Yeah. You. Okay.
No, I'm helping the guys.
Yeah,
over there.
for presentation.
Presentation, connecting people.
Yeah, good.
I'm just.
I think you have good. Yeah, you have good team here.
Yeah.
You have one responsible here, one for review, for question, one for poster.
Yes.
Good.
Philip is from Peru?
No, he's from Brazil. Felipe, Valencia.
Philip, yeah.
Yes. Rosa and Janessa from Peru,
Okay, yeah.
but Felipe is from
Because the morning she told this, he pronounced good the name. I think he's not from Brazil.
So where is your?
I'll put mine up
Did you
now.
put it out?
I'll put my WGPA second half.
The best way is to present. It's very difficult to present after no. You have good students, Janet. Isabel and the guy.
Yeah, they did well.
Yeah, good.
What happens is Edgero upsets everything and Polycenthia doesn't let me get on. It's such a pain.
Who present this session, Alison? You?
Oh, I don't know, possibly. If I can get on the, good, looks as though we're on. I'll put it up in the folder. Presentation day 2. I'm sorry I don't know what time it is. So I have to,
I didn't have your English, Alison.
Sorry?
I didn't have your English or the English of Sheila.
I don't know, sorry. What did you say?
I didn't have your English, your communication.
You didn't have?
Yeah, I need this.
When was this?
Recording in progress.
That is past tense, so I can't help you. Oh, I know. Which one? Meeting 6. There we are. It's going up there now. So I'm sorry. I have 2. I have
Which is yours?
WDPA.
Okay, yeah.
Hey.
I didn't.
No. It's finished now. It's about as finished as it's gonna get. So.
No, it's not that one. It's 15. It may not have appeared yet. I have to refresh.
Which is
It's not there. There it is.
We brought you a sandwich.
Oh, I mean,
We did.
Oh, geez.
We did. So we want you to eat a moment ago.
Alright, I am thinking just for just a minute.
Can't do the grass. So oh, this is thank you. Wow. Need a new t-shirt. I do it. Mrs. Minerva. Oh, I like Romeu Landi. Great product.
Absolutely.
Oh, brilliant.
This is so
Oh, that is very good. I love the Minerva. Yeah. Oh, and she's on her horse. She's got her horse. Oh, thank you. Thank you. Oh, very nice.
Special.
Oh, thank you. That's fantastic. Oh, very good. Oh,
I'm going to be all rage.
we are going to be definitely.
All right. So I'm going to get your sandwich ready.
Shiri, because Alison have presentation. I think you can present the session. Because Alison have another.
Well, how about
Me and after me, Janet and Janet Danton, and after Danton, Alison, and after Jimmy. 5 presentation.
Okay, hold on. I didn't prepare.
Yeah. Because our next one. schon, präsent Frau Lea, Janeiro. For the 2 weeks you work with the same written. For the next 2 weeks you work with as Alison said here to I didn't think so. You start you start 9 a.m. to 4 p.m.
Never worked that much as I.
Exactly. I didn't but there is many things to do. dia.
Bom dia.
Bonjour.
Bom dia.
Janet.
Oh, what is the afternoon? Boa tarde. Boa tarde. Ardy. Or good afternoon and welcome back from lunch. So this afternoon we're going to have some really interesting speakers. So yesterday we talked about what the goals of PARSEC are. And today we're going to walk through some of the early results or mid results and share those with you from each of our speakers. Our first speaker is one of our incredible postdocs. You already know Janeth quite well. Ali Ben Abbas is our other postdoc, and he has been with the PARSEC Scholar project for quite some time. And does participate on the synthesis. I can't even pronounce English. This is not going well. The synthesis science strand, and one of our connections between the two strands is through the postdocs, Janeth and Ali. So this is one of the ways that we stay connected. And he specializes in artificial intelligence and machine learning, received his PhD in computer science from the National School of Computer Science in the University of Manouba in Tunisia, and the University of Clermont-Ferrand in France. And that was in 2016. So Ali, are you ready to take it away?
Okay, thank you, Shelly. Okay, before start, I would thank Professor Pedro for this invitation and organization. Also, I would thank all PI, Alison Shelley for PARSEC project. And I thanks also my team in France and for the Foundation Research of Biodiversity. So, as Shelly said yesterday, you have just presented the PARSEC project goal, the research question about PARSEC. And today, we will present some results of PARSEC for different countries. We will start by East Africa. For this, I start by present the general context of our project. As Alison said yesterday, the goal of PARSEC is to use a combination between satellite image and deep learning in order to support the Sustainable Development Goals. So, for the satellite image as an important information source for many applications. For satellite, you have many sensor data available for satellite with different spatial resolution. The spatial resolution is the size of the pixel, and with different also temporal resolution, also with different spectral bands. So usually you can use directly the satellite image as information, but also we can extract some specific indices from the satellite image. For example, for vegetation, there are some indices like NDVI or in specific indices for the urban. And the information of remote sensing, you can add other data as socioeconomic, as soil, for example, and before that, there are data fusion in order to prepare, to make some preprocessing before the deep learning method. So, for the deep learning challenge, there are two challenges for the deep learning. First of all, how to select the best model select the best model, and how to select the best hyperparameter in order to support for decision making and for general for the 17 sustainable development goals. So now with satellite image and deep learning, we can, for example, forecast the cereal yield for the SDG 2 food security. You can estimate poverty. You can also anticipate the climatic change in order to reduce their impact. There are many applications of this magic combination between satellite images and deep learning. And today, there are many initiatives in the world to develop a data cube that use many satellite images in order for many applications. For example, the data cube Brazilian created by the INPE. There are also Swiss data cube, Australian data cube, China data cube. There are many data cube now in order to support the environmental applications. So now, in the context of PARSEC, our objective is to evaluate the impact of protected area. For example, there are two types, terrestrial or marine protected area, to evaluate the impact, socio-economic impact of the protected area using a long time series, and in order to make some before and after comparison for using satellite and socio-economic data. So, as you presented yesterday, the same goal for six regions: Brazil, East Africa, Australia, Japan, France, and United States. The same goal is to make some before and after comparison to assess the impact of the protected area. So you use the same methodology. First of all, you select some protected area. After that, you selected some village treated, the village that close the protected area, and you make some using some matching algorithm to select other control village that share the same property that the treated village, but is so far from the protected area. And in order to estimate the socioeconomic outcome, as well as to track change over time. So the generic methodology used by PARSEC entities consists on 3 steps. First of all, our aim is to training deep learning based on socioeconomic data, based on variable from socioeconomic survey. After that, you download the satellite image based on the geographic coordinate of the socioeconomic, and training our deep learning. But before that training, there are some method to split our data to train and test and validation. The second step is the selection of the marine protected area and the village. So you first of all you select the MPI and you select the treated village. First selection of the candidate mirror village, and after that you make some matching algorithm to make the final selection of mirror and treated, to make some before and after comparison. So today I will present our case study for East Africa that we have worked on Mozambique, Tanzania, Madagascar, and Comor. So for the selection of the MPR, you have used for this step was done by David Mouillet and Rodolphe and Vincent Delbar for this steps for selection. They have used the WDPR database of protected area to select the protected area in 4 countries based on some criteria as you show, from the distance from the coast, from with size at least 1 square kilometer, and select the MPI that created between 90 and 2015. Finally, they have selected the 16 MPI in the 4 countries. And here there are some information about the number of the protected area by country. Here the type of category of MPI by the selected, and here the surface size by country. For the second step is to select the treated village. Here for the treated village, they have used the OpenStreetMap for the selection of the treated village, with also some criteria within 30 kilometers, for example, from the MPI selection and other criteria, as you say. And finally, they have selected 96 villages. Here's some information about the number of the selected village in by country and the number by MPI. So here for the control village, the idea is for the control village is to select some village so far from the MPI and have the same property than the treated village before the construction of MPI. And for the matching, they have used many descriptor about the land use, land cover, the climatic data, also the wealth index used by estimated by deep learning, and other in order to select the control village. So now for the deep learning model, you have used reproduced and replicated after the recent paper of Ye and all the paper that published in Nature, and you have considered as a reference paper in the topic because there are good results and have used huge data of socioeconomic. So the flow chart of this methodology, first of all, you have calculated the wealth index from the socioeconomic survey. After that, you have downloaded the night light. You have used 2 sensors, the Landsat as daytime with the 30-meter resolution, and night light also with night light. And you download the satellite image based on the geographic coordinate for the socioeconomic here. And after the third step is to make data split. Data split is in order to split the data in train, validation, and test. And after that, finally, you make the training of deep learning. So from for the construction of the wealth index, here you have used DHS, Demographic and Health Survey. The wealth index was constructed from the first compound of principal compound analysis using 11 variables from DHS at household level. And after that, you have calculated the average by village. So you have started by calculate at household level, and after that, you have calculated the average by village. Here, for the variable that you have used, just the variable about socioeconomic, that's for the quality of water, if the number of occupied room, car, telephone, radio, some variable for DHS. Okay, and here, for example, there are this is the correspondence between the wealth index and the satellite image in the village, for example, with size around the 6 kilometer. Here the red point is the household, and the lat long center for each village. We have downloaded the satellite image here, for example, with a Landsat with 30 meter, and also you calculate the wealth index. Finally, you have found the 1993 survey for 25 countries from 96 to 2019, and for our study area, Madagascar, you have found 5 survey, for Mozambique 4 survey, Comor just 1, and as you see here, all I think around 600 villages in Africa. Here, I will show you the correspondence between the satellite image and the wealth index. For this, I have used the highest wealth for Angola. As you see here, the 7th band of Landsat, and the last is night light, and also the lowest wealth. Also the 7 RGB. The first is RGB. As you see here, the white is some building close to coast. Here some hotel and some other building. And here, for example, for the night light is no information for the lowest information. That's the idea for this, because the information from the night light and the Landsat is not the same information. The night light is based on electricity, and the Landsat is based on the land use, land cover, and some building. Here, before training, so our propose for this work is to propose a generalizable model. So before training, it is interesting to make an adaptive split of data, because you can put the same information for two split. For example, you can, because here the village are very close, with the size of satellite image around 6 kilometers. So there is an overlap between the satellite image. So if you put the same information in the training and test split, there are picking for the testing. So in order to make generalizable our deep learning, there are two configurations to make to assign the same the village with the satellite overlap satellite image in the same fold. For this, there are two configurations. The first one is out of country, consists to put all one country to one split. As you see here, Madagascar from split B, I think. Didn't see. And the second solution is to calculate the distance between the village and put the village close in the same fold. Is the in country. And I think after the performance, we have calculated the DHS in country is more better than the DHS out of country. Here, I would present the split by country using in country. That for this figure, you can, for example, whenever the distance between the survey is so far, the deep learning, the performance of deep learning will be good, well. So the conclusion for this, the deep learning is, you can use the deep learning is not only for the estimation, but We can use the deep learning also to guide the survey in the future. Because here, for example, for the Comore, if the survey are the village are very close, and also the Comore is when, for example, for Angola is the performance of Angola, when you calculate the performance by country, you found that, for example, for Angola is better than Comore, because here in Comore and Lesotho, the survey are very close. So deep learning, you can also use it for the guide the survey in the future. Here you have tested many configuration for deep learning, many combination. You have tested multispectral only, night light only, or the combination between, or the RGB, just the three first bands of Landsat. And for the deep learning, for this you have used the pre-trained CNN. This is a pre-trained CNN ResNet 18. Here there are the first selection of the treated and mirror village before matching, and here when you have used the estimation and the other, and this is a climatic land use to make, and after that we have selected just 97 pairs to make the after and comparison. Just you calculate delta, the difference between treated and mirror village, and make a time series in the time, and calculate the delta to check after and before the construction, the marine protected area. Here the work is in progress. Thus I have tried to calculate delta for the 97 pair by MPI. And the red line is consists to a year of the construction of the MPI, but is not final results. And it should the expert in ecological form to make interpretation. And also here for the computer science view, I have the model can be used for many other applications. Here, for example, I present you just a mapping, spatio-temporal mapping of poverty in the time for Madagascar at pixel level, with pixel width around 6 kilometers. Here it is at pixel level and also at district level to make spatio-temporal mapping that we can use it for many decision-making applications and other contexts. And we have checked this result with other results in different paper and or other reference. So that's my presentation. After that, I think Jeanette, we will you have talked with Jeanette about the reproducibility and about the problem that we have had with the reproducibility of with the year. And tomorrow I will have a hands to make some experimentation with the student from the for our experimentation. And thank you.
Does anybody have any questions? You want to? Okay.
Hi. To evaluate the wealth of a village or something like that, do you specify the coordinates of the village and then use the image of that coordinate, or do you just like run the model for any image and detect the wealth from the image? I'm asking that because I was wondering how the model behaves if you just shows it like an empty area and where there are no villages.
I didn't understand your question about the geographic coordination for the village.
Yes, so
this information was extracted from the DHS survey. You have this information about the village And for each village, you have a center of that geographic coordinate.
Okay. Okay. But so you don't use the model to kind of do. You only use the model on top of look where in coordinates where there are villages located.
No, that's the object, the goal of the presentation of Jeannette. After you have used the same model with transfer strategy for other countries. We will use a proxy information here, additional information, the night light, to use the same model for other countries. We have started with the Brazil, with the Japan, and Australia also, and we have some good results.
Okay, thank you.
Anybody else?
So I'm going to make 2 questions. So the first one is, you built this analysis based on the hypothesis that more intense night light is associated with human development.
Yeah.
That is true.
Yeah, yeah.
And is this association common? I mean, if you go to a developed country,
okay.
Is the night light intensity correlated with human development?
Yeah.
And just another question so that I can finish.
Just for the first question, is not the same information in the night light and the Landsat. It's not the same information. The night light is based on the electricity, and the Landsat is based on the land use, land cover.
Mm-hmm.
So it's not the same information. You can use just night light for night light, but here, for example, the combination, when you combine it, is outperformed other configuration if you use night light or multispectral only.
Okay, so you are using as features both the night light and the land.
Exactly.
Okay,
you extract the future from night light, the future from Landsat. You use the ridge regression for the concatenation between the 2 futures. But using the transfer learning, you have used for night light and for multispectral. And we didn't have the same information with night light and use in the time for.
I see.
It will be useful to use the 2 information from night light and land use.
I was just thinking if there is really a correlation between the intensity of night light and human development. Because if you go to let's say, a metropolis, you have a lot of light there, but you may have a lot of poverty and inequality. So I was just thinking that this is very complex. And that would be my second question. If you ever considered using a Gini inequality index or some inequality index in addition to the wealth index that you developed.
Exactly, that's the idea for some future work, is to with the wealth index integrate other indices, because when I found in Africa there are some indices are available than the wealth poverty, as water, education, health, and you can use some multitask learning because you will use the same input images and to predict and and all this index are very correlated, and you can use the information of other indices to improve the estimation for the wealth index. I have discussed with Jeannette about this idea to use multitask using many indices to improve this. Because in DHS there are many data about the health, about the children, about some other education, and it will be, I think, good idea to combine all indices.
So it's a work in progress. Thanks for your answers.
Professor Pedro, there's a question up front here.
Thank you, Ali, for the presentation. I'll make one for the crowd, but it's mine.
Thank you.
Okay, so in the work I just presented, we saw a surge, a huge deforestation that happened here in, it was about 94 to 97.
Yeah.
I'm asking you, do you have any suggestion how could we find any correlation with any human activity at that time? What indexes would you suggest for us in our work? Because as I see that you correlate lights or everything, do you have any idea what we could use to detect these changes, why this have changed?
I didn't understand.
Yeah, well,
Okay.
yeah, it's kind of a vague question, but
Yeah.
anyway, well, we detect the spike in deforestation during like 4 years. So I understand that you cross indicators, social indicators or light indicators.
Yeah.
So what I was asking is, do you have any suggestion for us in our work? Anything that we could add to help us identify why this thing happened? What could we correlate to that? Do you have any thoughts on that?
Just for now, the solution is to apply the transfer learning. If, for example, for the Brazil or other countries, if they didn't have size enough to train the deep learning, I think the same. The only solution to make transfer learning, and before they make the transfer learning, it should be check the correlation between, for example, here the human development index that will be for 10 every 10 years. I think is you can check and you can add it as additional information, additional as a proxy, for example, to night light between the sustainable development.
Thank you.
Thank you.
Any additional questions? All right, I know we're running a little bit behind, so I guess we'll move forward. Ali, thank you so much.
Thank you.
Oh, fantastic. Go right ahead. So next on our agenda is Jeanette, who's our other postdoc, and she's setting up her presentation right now. She is tech and all of that at the same time. There is no technical problem she cannot solve. I'll go ahead and introduce her. So she's a member of the PARSEC data strand and synthesis strand, so another key liaison between the two parts of the project, and has a Bachelor of Science degree with a major in computer science from San Agustin University out of Peru, and a Master of Science and PhD in computational physics from here at the University of São Paulo. And I would like to introduce to you, Jeanette.
Thank you, Shelley. Okay, and thank you everybody to be part of this workshop. Thank you also for this opportunity and for having me, and Professor Pedro as well for giving me the opportunity to be part of this PARSEC project and my postdoc as well. So just to continue with the idea that Ali has wonderfully presented about the training on the Africa, and he was also answering questions from Marcio regarding the white, and what about the people that don't have data sets enough to train a model, since we know that many deep learning models use or need to be enough data to have a good performance and accuracy and so on. So the idea is to use a deep learning model on an enough or huge data set like Africa, and to make transfer learning for other places, countries that they don't have enough data for the training. And this is a particular case with the Brazilian case. And you may be wondering, why don't we use training a model from scratch and to train with the data set from Brazil? We can do that. Okay. The problem of that is that, for instance, the indicators that Brazil has, such as the HDA, which is Human Development Index, it is only available on census. And the last census was in 2010, 10 years ago. Now it's going to be 2022. So we don't have enough census to train for a time series an estimation for making projections. So that's why we use transfer learning, and this is a topic. It's going to be about that. So as I mentioned, we have many opportunities to have these predicting or estimating socioeconomical indicators so that we can make politicians decisions, making efforts to sustainable development. And also, one other important thing is that how do we obtain this data? It's by obtaining these socioeconomic indicators. But the fact is that it's expensive to obtain. The only way we can obtain is by making census. To make a census, it's very expensive, time-consuming, money-consuming, and so on. And it's good, okay? And so these proposals, what we are making in this PARSEC project, is to try an alternative with so a tool that helps to obtain these projections of socioeconomical indicators. So as I mentioned, the census are collected every 10 years. So for instance, in Brazil, we have the IBG, which is the institution that provides and collects data from surveys in Brazil. And so the proposal is not only about remote sensing imagery, but also there is plenty of other data that could also be used as an alternative data sets like aerial imagery, remote sensing, street view imagery, so that could be also accessible and they are low cost so that they can be used as a data. So in this short presentation, what I'm going to present is just how the data set, how we infer the indicators, in this case well-being or socioeconomic indicators, by using transfer learning. So we have made this training deep learning model in Africa's countries, okay? And we apply it to the Brazilian context to see, to make some estimations. So specifically, we made experiments with Vale do Ribeira, okay? So we have three things in our models, which is the area study, which is Vale do Ribeira. We have that deep learning model that has been trained before, that he and Ali also has explained it well, which was trained in Africa's country. And we have the data set from satellite imagery using these two kind of imagery, which is one multispectral, which is daylight, diurn lights, and night lights. Why? Because they have shown to be plenty information, rich information of satellite imagery that contains correlation with socioeconomical indicators. So regarding the area, this is Vale do Ribeira, which is located at the southeast of São Paulo, between São Paulo and Paraná. So we have these two states. So it's a huge area with plenty, I think it's 30 municipalities, okay? And more than 90, almost 1,000 census tracts, okay? Census tracts here is our lowest granularity, which is the smallest granularity that the IBG, which is our census, that collects in a neighborhood and they make census. So we are looking for socioeconomical to estimate at the level of census tracts, sorry. And why we are studying Vale do Ribeira? Well, it's a largest contiguous area, protected area, okay? And it's also a natural heritage and represents 21% of the remaining forests in the country. So it's very important in the socioeconomical aspects and natural conservatory aspects as well. Also, Vale do Ribeira is surrounded by many protected areas. So This is something very interesting because these people that lives here, and we forget, right? We are always speaking about data, but we forget about the people that lives actually there. So these people, some of them depends on these protected areas, and this is also another study that if these protected areas has influences their life. How do we do that? By making estimation of their well-being, their socioeconomical indexes. So the training model, as Ali has also presented, this data, this model was trained in a period of 1996 to 2011, more than 20 years. It was trained, it's a huge data set, was trained in 24 countries, so almost 1/3 of Africa. Okay, so it's a continent. These surveys, which is, for instance, number of rooms, electricity, the house floor, if they have toilet, phones, radio, all of these surveys were made a wealth index. So I put it here, wealth index in apostrophes, because it was calculated using PCA. So it's kind of a new index based on the summary of this information to construct this wealth index. So the model was trained with this data set. And after that, it obtained, for instance, here it's how it was trained with using two kind of imagery, multispectral and night lights. Each of them with their Landsat bats were trained with a ResNet model, same with the night lights, and they were merged. They merged their information, and they give you the model. So it was trained on that. And the biggest and the highest performance was 0.69, almost 0.7, which is on the top, on the baseline with the other papers that are on literature. So it's a good one performance for to make estimations from satellite images. So also regarding the data set, we used these two kind of data sets, okay, night lights and multispectral. And here are some samples of imagery, just to mention that the night lights were the source for this one is DMSP, which is a resolution of less than 1 kilometer per pixel, which is a high resolution. And this is the other one, the daytime, which is also based on Landsat. So this imagery were composite. For instance, we cannot download it only 1 year and train it with that. But my composing images 1 year earlier and 1 year before, so that we make an average of this image, so that we avoid clouds and everything, so that the image is the best, the most cleanest with clouds and so on. So that's the data set. Oh, and one point is that this image corresponds to the years from 2010, 2015, and 2020. Okay? The last survey was 2010. So we are trying to make estimations for these also 2 years, 2015 and 2020. So here are some of the results. This is not published yet, but it's now on the web. This is the estimated wealth index from 2010. From here, we are seeing the heat map from minus 0.66 and 1 for 14, which is mean the lowest poverty, like well-being, or the lowest well-being and the highest. And we are observing here the estimated on Valle do Ribeira. Okay, so we are from just observing this, we can say that most of these regions has obtained a very low wealth index in apostrophes. Okay, and we are seeing also these spots here in hot, which mean that they are more rich in or high well-being. How do we validate the model is that these sectors that are from here corresponds also to the people that live there that has high for instance, urban people. So the most people that lives here are correspondents to urban. So the places that are in hot corresponds also to urban sites, urban tracts, which is also indicates that they are more developed than the places that are rural, right? So we have this urban and rural. Here, just to make an example of the distribution of the urban and rural. So it's also on the same correlation between these, where there is rural, there is also more well-being, and where is urban, it's also low well-being. To validate, so we make correlations. So how would we validate? Because this model were trained with DHS, which is a survey from Africa, more in Africa. Of course, there are other countries, but not in Brazil, not in 2010, and not with geolocalized. So we make only correlations with the HDI, which is the Human Development Index from income, to make a correlation with the estimated well index from 2010. And we obtained a 0.5, which is a good value, which means that they are well correlated. Besides, the performance of the model was 0.7, so of course it's going to be a little decrease, but it means that it is high correlated, which is what's also showing by with the previous maps with rural and urban sites. Here is also the estimations from 3 other years, 2010, which is our census, 2015, so this is future, for instance, and 2020. So we have the availability of these data sets. Of course, this wealth index is not going to evolve as quickly. So the human development, the increase or evolves slowly, just like it in fact does. So we are seeing a kind of evolution of these socioeconomic indicators. And one other question that is very interesting for him, from here, is that if these people that live here, have they evolved, have they become more rich between 2010 to 2020? So we made also plots of the trending. For instance, here only the census tracts and the estimations. And these curves represents the wealth index from 2010 to 2020. And we are seeing some slopes, so they are positively increasing among them. And also we made a comparison. For instance, if they have a positive trend, so we put it in green, and if they have a negative, they are going to in red. So, for instance, here we can say that most of these rural people has been evolved positively, so they have been more well-being in this lapse of time. Okay. So just for conclusion, since we are still finishing this work and we are going to publish, the idea is that, so we have now this beautiful tool with deep learning and satellite images, and how they can be used for to make a tool for decision making for the people and governments, how it's the potential to be used in another surveys. For instance, we are going to have now the survey in 2022, hopefully, or from this year, maybe. And the next step, so it's to investigate how these socioeconomic estimators have impacted regarding the effects of having protected areas around them, about the municipalities that are near to these protected areas. So, thank you. That's all.
Any questions for Jeanette?
Yeah.
It is more a suggestion than a question. First, congratulations for the work. It's very okay. But a suggestion, think on how robust should be the model with the things you have lived. For instance, the pandemic. So you put something in 2010, 2015, 2020. There is a singularity between 2015 and 2020. So how the model you handle that, or a compensation. As you know, L1 and L2 in factors when you do machine learning models to compensate these things because it's a normality. So how, one suggestion to improve the model, how to turn the model when you have this kind of singularity. Another thing, 2014, 2015 to 16, we have a huge economic problem in the country. So you can eventually, for instance, a suggestion to link to the inflation or the rate of the inflation, up or down, the derivative, not the absolute value. Just a suggestion, but congratulations.
No, thank you, Andre.
Okay.
Yeah, indeed. That is something also that, for instance, we are trying to make this same thing, the model in Japan, where they have also concern with the COVID and the tsunami. But these are those two kind of things that has happened. For instance, one is social, because COVID is kind of social, and the other one is like natural disasters, so they have impacts in the images. But indeed, they are going to affect the model, right? But thank you, Andre.
Additional questions? No?
So I'm very clear, so no questions. Okay.
All right.
Thank you, thank you.
Thank you. Janetta, you could
Yes, Kondo-san. Yep.
Our teammates from Japan, of course, this is a terrible time for them. So we do have a recording from Kando-san, from Yasuhiro Kando-san. He's an associate professor at the Research Institute for Humanity and Nature in Japan. He's our country lead for the synthesis science strand as part of PARSEC. His background is in spatial analysis and archaeology, and he's currently coordinating the Open Team Science Project at his institution to develop a methodology to overcome knowledge gaps between research experts in different fields and societal actors in socio-environmental issues. One moment, we'll have his talk. For questions on his talk, we will have to share those and get back to you on it.
Particularly in Japan. This research collaborates with Satoko Suetsugu-san, Osawa-san, Janet, Danton, Ali, and Professor Pedro.
That would be amazing, but very cruel to him. Yep. I will give Kando-san credit, though. He, for many of our PARSEC meetings that were combined, he was the one who got up at 3 a.m. and did tough through it. So just really very dedicated.
Because we have a half-day time lag between Brazil and Japan. I missed the in-person symposium. Anyway. Anyway, it's my great honor to present my ongoing research to the audience in Brazil today. My talk is on the pandemic effect on tourism, particularly in Japan. This research collaborates with Satoko Suetsugu-san, Osawa-san, Janet, Danton, Ali, and Professor Pedro. protected areas, or PAs, of Japan have some peculiar characteristics. Japan holds land of 37,000 square kilometers. It is roughly equivalent to the area in the sum of Brazilian states of São Paulo, Rio de Janeiro, and Espírito Santo. The population of Japan last month counts nearly 125 million. In Japan, the National Parks Act was established in 1933. 31 first. So far, 34 national parks have been designated. They cover 22,000 square kilometers, corresponding to 5.8% of the national land. Unlike the United States and Australia, the management of protected areas in Japan is characterized by patchy land ownership and governance. Private land accounts for 13% of the national parks and 1.9 million people live in national park areas. Moreover, there are institutional fragmentation and overlaps in authorities and legal systems. This table shows a classification of PAs in IUCN and Japan. National parks defined by IUCN Category 2 are corresponding to national and quasi-national parks in Japanese system. Some Japanese national parks are also small that they belong to a different category, typically number 5 in IUCN. Other than national parks, nature reserves corresponding to IUCN Category 1 are managed by the Nature Conservation Act, and natural monument, IUCN Category 3, are controlled by the Cultural Asset Preservation Act. Such a mixture of legal system makes holistic management difficult. Our research interest is to assess the socio-economic effects of the recent tourism promotion to national parks in Japan, but the COVID-19 pandemic disrupted that. In 2017, the Ministry of the Environment, or MOE, designated special economic zones in 8 national parks and 3 quasi-national parks to promote inbound tourism. The ministry expected accelerated growth of inbound tourism with an increasing number of tourists coming from China, Taiwan, South Korea, ASEAN countries, Australia, Europe, North America, and other regions in the world. However, the pandemic ended this expectation. So, our research question is issue-driven. How did the COVID-19 pandemic affect the socio-economic growth of the special economic zones? Is the effect different from non-designated PAs as a potential mirror? We are trying to check these questions with the PARSEC method presented earlier in this symposium. Nonetheless, there are some methodological constraints. We must apply the project objective, site selection criteria, and analytical method. In practice, regarding the objective, we must take PAs into account. We must follow the site criteria that the French colleagues set, and we must have mirror sites distance from any PAs. For the analytical method, we must apply the same method introduced in the East African and Brazilian cases, such as DHS, HDI, Google Street View and satellite images. External data availability also matters. The COVID-19 pandemic happened in the early 2020, and the national statistics for that year have not yet been available. Regarding site selection, for example, we prefer studying the 11 national parks designated by the Visit National Park project. Still, most of them are older than the criterion. Only one World Heritage Site at Ogasawara Island matches the full criteria. To adapt to the criteria, we added 9 national forest ecosystem reserves, FER, designated in the limited period between 1995 and 2008. These reserves correspond to ISN category 1B. Now we have 21 PAs selected. Of these, we focus on Kita Tohoku, the northern part of the Northeast Japan region, for a pilot study in collaboration with the Brazilian team. This is a regional map for 3 prefectures or provinces of Kita Tohoku, namely Aomori, Iwate, and Akita. This region occupies more than 36,000 square kilometers, accounting for 10% of the country. The population was 3.4 million in 2019. This region is one of Japan's most seriously depopulating and aging communities. Meanwhile, this region is rich in ecological and cultural resources, which I will show in the next slide. There are 2 areas of one united national park toward the Hachimantai and one forestry ecosystem reserve, Osorezan, namely the Mountain of Fear in the Shimokita Peninsula. Also, as this picture shows, East Coast communities were devastated by the tsunami in March 2011. Here we see some nice pictures of Kita Tohoku region's major ecological and cultural resources. These images are well represented by Hayao Miyazaki's animation movie, Princess Momonoke. This is a nebuta float in the festival of Aomori. This is Namahage, a traditional monster celebrating families and children in Akita. These cultures stem from the Jomon period, some 5,000 years old. There are also beautiful forest and mountain ecosystems. Tourism in this region is potentially promising. However, the tourism sector of this region experienced a rise and fall as entire Japan did. The number of tourists visiting toward the Hachimantai National Park, represented by annual statistics in blue bars, gradually increased from 1970s to 1994 and then steadily dropped slightly. This pattern is relevant to the national trends in green lines and is in parallel with an economic setback. It experienced a sharp decline in 2011, the year of great earthquake and tsunami. Then the number of tourists slightly recovered, but it reduced again by half during the pandemic. We had a kind of serendipity in the site selection process. The Brazilian colleagues selected municipalities or local communities for analyzing this using the systematic criteria that Janet presented in this symposium. As a result, the selection excluded populated places such as Aomori, Hirosaki, Hachinohe, Morioka, Ichinoseki, and Akita cities. 5 municipalities close to Towada Hachimantai National Park were selected for tourism group, highlighted in yellow, and the other 5 in the Shimokitai Peninsula were chosen for non-tourism group, highlighted in magenta. Other 5 municipalities, distance from national parks, FER, and populated cities were selected as mirror site groups, highlighted in blue. This systematic selection is quite interesting to me through the lens of actual socio-economic situation of the region. For example, Oma town at the northern end of Shimokitai Peninsula is well known with tuna fishery. OTS on the east coast stands for Otsuchi town, which is the most severely damaged by the tsunami in 2011. KGS stands for Kanegasaki town, where a new large-scale industry complex is located. Similarly, a new roadside shopping complex opened in 2016 in Ugo town here, attracting Japanese tourists and local inhabitants. We should consider these socioeconomic factors when assessing the effect of protected areas. This table shows a preliminary result of Janet's work highlighting diachronic trends of the poverty proxy per selected municipality using daylight and nightlight images. Please remind the two events, the tsunami in 2011 and the pandemic in 2020. Interestingly, nightlight images work significantly. Most strikingly, nightlight reduced all selected municipalities from 2000 to 2022, but somewhat recovered during the pandemic from 2019 to 2022. This diachronic pattern of nightlight is somewhat controversial to the actual income indicator. This chart shows annual taxable income per taxpayer from 2010 to 2020. In a general trend, the income has slightly increased for these 10 years. It seems that the tsunami and also pandemic did not significantly affect income. There were 2 abrupt increases. The one is for Oma in 2015, when the town had a big catch of tuna. Yokohama town had a big catch of farmed scallops in 2017 and 18. We cannot distinguish the tourism factors from these remarkable economic episodes. The next step will be to replace Human Dimension Index HDI, because that should be used for international comparison, but it does not capture the distribution of extent of poverty within the country. So also ethical, legal, and social issues, LC matters to analyze the poverty at the census tract level. That is what my experience. So we replace HDI with a more scientifically reliable and politically and ethically correct index like Inclusive Wealth Index, IWI. As time is limited for now, we will present it on another occasion. That's all. I will miss questions and answers and comments today, but please contact me if you have any feedback. Thank you very much for listening. Bye-bye.
I feel like I should not even attempt to ask any questions. Allison, what would be the best way? Should we provide Kondo-san's email, or maybe we could collect them? It was just up there, wasn't it?
Hello, my name is Yasuhisa Kondo. This is a pre-recording.
All right, very good. So please do reach out to Kondo-san. He would be delighted to answer any questions. And as with anyone who does not speak your primary language, try to be very articulate and verbose, many words, very descriptive as you can so that he understands what your question is. All right, we have our next speaker coming up. I'm going to talk slowly because she's currently busy talking to someone else. So I'm just going to vamp a little bit here. She's amazing, though, I'll tell you that.
Sorry, I wasn't listening. My apologies. My ears weren't going. Should we have afternoon tea before?
Oh, should we? Do we want tea first? Is that why you're looking at me? Oh, okay. And of course, we all know it's not tea, right? We call it afternoon tea, but we all know there's no tea.
Yeah, maybe we should say something about Kondo-san.
Would you like a moment to do that?
Yeah, I might just do that. This is the first of probably a couple of talks where it has become apparent due to the transnational, the international work, that the model has to be adjusted for the different countries. So the model you heard from David and Rudolph, which is well founded in, as you can see, a Nature paper and various other theories, and some massive data sets for Eastern Africa, works quite well, it appears, for developing countries. But when we move into denser countries like Japan, where we don't have the separation between a town and a protected area, or between towns, or towns and other activities, and you've already mentioned events, industrial activity is another thing we can think of. We've had to adjust or think about a great deal how to carry forward as a team and use the techniques that we're developing in one place to apply them in another place in maybe a different synthesis hypothesis. So this is the first of at least two examples of this. So we'll hear more later. But yeah, it's an interesting aspect of the consequence of internationality. So that's for Nicole and for the audience. So thank you very much. Are we going to have morning something, tea, coffee?
We'll have the arc and tea.
Okay.
That's right. Is ready.
Okay, so we might, audience from outside, I'm not sure how many people are there. Thank you very much. We'll take a 15-minute break, and then we'll move on, and you'll hear from Australia and the US, and we'll keep on going. Okay. between you and me. Yeah. So we will finish. And Pedro, did you hear? We shouldn't be too long. I'll be as quick as I can because Jamie Martello is taking Jamie and the others to the soccer museum. Oh, yeah. After. No. I don't have any voices. Yeah. And I like it. Isn't that lovely?
In the northeast restaurant is not so far from the hotel. 10 minutes left.
There was an idea that maybe Nicole could be presented before him. So because she's leaving today.
She's
No,
she's here till Thursday.
No, she's leaving.
She's here till Thursday.
Yeah. No, tomorrow she will come back.
Yeah, she's just coming
during the morning.
Yeah, Alisa told me that.
Who did?
Ali.
Okay. I think, but do check.
Yeah, it's okay.
Okay.
A apresentação tá pronta?
We have a presentation.
Rafael?
That's Rafael.
Rafael.
Yeah, yes. We've got Minerva. We have Minerva here.
Rafael, Minerva?
Yeah, it's pretty good here.
You are protected.
We are protected. We are protected.
You ask to Rafael. Is everything okay?
Okay.
No.
Welcome back. I know you are so excited.
Jeebus.
You could not wait for the next talk. I just know you were all talking about, what is Allison going to say?
No.
How can it get any better?
No, heaps.
We got heaps.
Heaps of talks. I better be quick.
Oh my goodness.
Oh, dear.
I double dog dare you about being quick. I don't think it can happen. So Allison Specht, who is a dear, dear friend because of the PARSEC project. We never would have met had it not been for the Belmont Forum. Where's Nicole? Thank you, Nicole. There we go. So Allison is an ecosystem research analyst at the Turn University of Queensland. Is Turn a university of Queensland?
No,
I didn't think so. There's a comma missing here. I don't want to say, this is your document I'm reading, I'm just letting you know. So at Turn, which is an environmental, how does that go?
Terrestrial ecosystem research infrastructure. I couldn't get its logo.
Of course. And she's also at the University of Queensland in Australia and did come all that way. She is the co-PI. There are 4 PIs on PARSEC, and Allison is started out as the overarching PI and had to make an adjustment if she moved from France to Australia, but it continues to be one of our co-PIs despite the fact that Australia is not part of the Belmont Forum family, which we will somehow help Nicole fix, but I'm not quite sure how we'll do that. And she makes sure that the 2 interwoven strands actually weave nicely together, and I'm incredibly grateful for all the work that she does. She's been teaching research and doing research in. Why didn't I edit your stuff? I mean, what did I do? You were gonna introduce yourself. Oh my Lord! For 30 years, period. Specializing in ecosystem processes, long-term observations, coalitions, mapping. That is not coalition. Collation, I think. Collation and mapping of biodiversity data with diverse sources, extreme natural events, and innovation, adoption for better conservation, and land management. Or it's my glasses. It might be my glasses. She's been a director of 2 synthesis science centers, and no kidding, that is like a lot of work. Established the International Synthesis Consortium, no kidding, humongous, and was the founding, it does say founding, working group member of Data One. And if you don't know Data One is, give Margaret a second, she'll explain Data One shortly. Tomorrow, come back tomorrow. Would you like this microphone?
Yeah.
Welcome to Allison.
Yes, thank you. I'm sorry about that, Shelley. I'm really sorry. That was obviously the long form. No, that was the long form. Very nice. Much better than I did. However, I have now looked at the agenda and people from outside, and I note that after me comes Jamie. After Jamie comes AWS, Cloud Infrastructure and Software Tools. Then there's too many talks. They'll never get to the soccer museum. Yes, okay. So I won't say whose fault this is, but anyway, it's everyone's fault. we all think we just can do it. You know, we can just rock through this stuff. Okay, I will try and rock through this stuff. Okay, so no, this is probably not very good stuff because I got right. So we have this theory that you have heard about now from David and from Rodolphe yesterday, and the execution of which you've heard a bit about today, and you're going to hear more from Ali and from Jeanette. Namely that you can gather all this stuff from in a before and after controlled impact of towns around protected areas and look at the effect of the creation of those protected area on some measure of wealth or well-being index across the globe. If you listened very carefully, you would have heard on Monday that David had admitted he had the initial thought that we could apply it uniformly across the globe, because there are wonderful things like the World Database for Protected Areas that had standardised records across the globe, and there were things like DHS, and Ali mentioned the meaning for that acronym, but the health survey, which is actually only done in more developing countries. But that was the initial idea, that everything could be wonderful. So that what you're going to hear about for the rest of the day is, and you've already heard about from Kondo-san in his wonderful talk, is an adaptation from that, because in Japan there were various physical and geographical reasons why that approach couldn't take place. There could be other reasons, but looking at the factor analysis that some of you have been doing, I'll call it factor analysis, where you have the most important principal component up the top and you move down, you only go past the first two and you say, we can't do it, right? We don't find out whether you couldn't do it for other reasons. So with Japan, the geographical challenge was there, and it is just wonderful to hear Kondo-san give a report and be so happy. And because I must say, a year ago, he was pretty miserable that he would not be able to execute and be part of the PARSEC project, and thanks to the Brazilian team. So we are giving you lots of credits, and to Ali, he has been able to make some mileage and use some of this innovative material. So remember those things we had about what we have to do in the Belmont Forum project to achieve innovation, technological transfer, translation, etc. We can do a few big ticks for Kondo-san, and that was only fixed up at our last face-to-face synthesis meeting. So this has been 6 months of great change for Kondo-san. Australia was not funded. So, as you've heard, out of Belmont, because we don't give money to Belmont. We think it's a good idea, we help host conferences, but we don't actually give the hard stuff. In which case, when I went back to Australia, I had to hawk this idea around. You knock on people's door and say, hey, do you want to buy this great idea? It's a really good idea. Anyway, and I didn't make much progress for a couple of years. Talked to all the good people in remote sensing, talked to all the good people all the people I kind of knew in socioeconomics. But then, and you will hear from them today, and I hope they're listening, and they will listen later, if not now, this team called ORAN, I managed to get in contact with. ORAN is the Australian Urban Research Infrastructure Network. They take the Australian Bureau of Statistics data, which comes from the census data, which you've heard about from Jeanette, which is the training data that we need for a project. So if Ali and Jeanette get the machine learning idea happening together and the model together, we couldn't apply it in Australia unless we had the socioeconomic data to train it. So that was absolutely vital. And I've only just, literally about 2 months ago, got onto these people, and they have been doing great things to help support. So this is, I've gone backwards, haven't I? This is, we've read that. This is the very moving target, and I think some of you may understand that this is the whole project is still moving. We certainly haven't got a definitive way of doing things, but we hope we'll get a better understanding and recommendations of doing things. This is the product of that very recent collaboration. And one of the reasons why I was busy today is that Germain, who is one of my co-authors, sent me on Monday some of the last census data, and I can't actually graph it. So I can't give you a beautiful graph. I can show you a table if you really want to see. But anyway, so what they were also able to do, which was a bonus, was they were able to use their work, rather than me having to ask the French, to collate the protected areas in Australia. And you'll hear later on this afternoon, you'll hear about the compatibility between this and between the WDPA and this particular instance of protected areas. So we've got all these protected areas in Australia, great country, lots of protected areas, lots of marine stuff, of course. As you can see, this is the Great Barrier Reef, which some of you would know. This is Nigaloo Reef up here, which is currently being blasted by, solar radiation again. And so we have these protected areas. I think I know what's in here. Okay, so that was the starting point 2 months ago with the team from Oran and the National Collaborative Research Infrastructure, of which turn the Ecosystem Observatory that I was part of is one. So first, telling you old stuff now, definition of protected areas. We have to then, this was the big bit that I couldn't do without some help. Namely, well, I could do it, but it was taking a long time. And I couldn't get the socioeconomic stuff. So associated towns with the rules. So Germain is a great, my co-author here, along with Ali and Jeanette, of course, who have been brought in to help very much so, is able to do a Python program and sweep through the towns, etc., and find me towns with the rules that you've all heard about. Now, the rules, as David also said, have to be a little bit flexible, and you'll see why, depending on the country. So, protected areas, associated towns, those within 20 kilometres of the protected area, of a certain size, 100 buildings, so not so tiny that you can't actually see them. And you've got associated towns, affected and unaffected. So ones that are close to the protected area, ones that are not. And that's not right. That's a duplicate, sorry. Because the mirrors are the unaffected towns, okay? So we'll talk a bit more about them. Eco-region is really important. Now, talking with Oren, they don't really think about eco-region, so that's been a really big thing. I'm still getting files that have eco-region kind of as an afterthought. So, you know, eco-region is something that we think about. We may not have mentioned this to you very much, but things like, you've heard about Katinga, you've heard about, and what's the other one? I keep on forgetting. You've heard about the rainforest. We have, and the people who live there have a different lifestyle because the soil and all those things gives them a different means of living and has done for 100 plus more years. So eco-region is very important for the socioeconomic well-being of the community, the development, the existing development, all those things. So eco-region is actually very important. So in order to run this theory, you have a protected area, you have in an eco-region, you have an affected town in that eco-region, you have another town, not next to the protected area, but still in the eco-region, so you're still growing potatoes or whatever you're doing. Okay, so, and those, then you would look at, just like a restoration project, you know, did my intervention make any difference? Did the creation of the protected area make any difference? So that's the theory. So Germain did his little Python magic rules, and we had our first meeting, and he has these lovely graphs because, of course, Australia is very big and no one lives in the middle, so you actually can't see the dots unless you put these little toothpicks on them, is his theory. I said, why have you got toothpicks on this map? Well, maybe it was chopsticks. I wasn't quite sure because they were very tall. But it's because you actually can't see the towns. So he selected 82 towns that were unaffected, supposedly that were close to a protected area, that were, you know, in scope, as we would say in the USA, in scope, and near a protected, close to a protected area. So you can see the Great Barrier Reef here. very long. It is actually a complex region, and I think Rodolphe talked about that. It's all sorts of different IUCN categories, so it can't be treated as a whole. That in itself is also a difficult thing to explain to someone from an urban research infrastructure network. But anyway, so they're having great fun, and I'm terribly pleased that they are having great fun. I hope they continue to, because it's of great benefit to me and to us in PARSEC. Okay, now the subsequent cut, which I got Friday last week, of the affected towns, is 35. We started with 82 in this big country called Australia, with lots and lots of, I've got numbers of protected areas, you'll find out how many. But of eco-regions, we have got not many. So anything next to the major capital cities, Sydney, Melbourne, Brisbane, gone. And they happen to be the most biodiverse. So you've actually got many eco-regions along the east coast where most people live. So there are most towns, there are most protected areas, because protected areas are beauty spots and things like that, among other things, next to people. So there's our list so far of the eco-regions, and I do actually have a number, but I couldn't find them because I was busy trying to do the graphs. So, right, so, okay, we've got our 35 towns, we've got a limited number of eco-regions, then we have to find the mirror towns. That's what we are trying to find. And we've got a suite of variables here. They come in and out as I choose. You've seen Jeanette's list and Ali's list. Sometimes I leave some of and David, I think he had a list too. We have a list. I mean, Australia's a very flat country. Altitude, I mean, there's about 3 places where there's actually something that you wouldn't call a hill. No, we've got a few mountains, but not many. So, you know, there's a few things that are not as relevant in Australia as they might be elsewhere. Roughness index. That's an adiabatic lapse-rate sort of roughness index. Okay, is it flux network stuff? Yeah, possibly is. Land use from MODIS. You know, there are all sorts of things like that. And that's been one of the learnings that David mentioned on yesterday that has become most important from the socio-economists, which is that we didn't think this at the beginning, or at least it wasn't spelt out, that the mirror towns and the affected towns have to be matched before the PA is produced. So you've got to have some of this data back in the day in order to match them properly. Did you note that? Yeah, so you probably knew that, but anyway, so that's interesting. So we have all of these things. It's going to be a very short talk. Okay, so at the moment, I am wrestling and at least working with the group, because I have all of 19 mirror towns at the moment. They're not matching every control town. 19 out of 35. So we've got 35 affected towns, or not control, affected towns, and only 19 mirror towns. So that's not adequate. So we're playing around with what can we do? Is there something that we're not doing? Is there something that we're not thinking about? Okay, all right, so let's assume we get them right. We get 35 and 35, which is pretty good, which would give us, according to David's statistics when he had this idea of the global comparison, 35 per country would be good. But if we're not doing the global comparison, and we've got different eco-regions within there, and we've got different IUCN levels, how much does that matter and lend to variability that I've been harking about all today? So we'll see. But if you have pair-to-pair, you can look, you know, they're going to be the same, so hopefully it won't be too bad. So once we've got them, we've then got to have the socioeconomic data sources, and of course, stuff for remote sensing. So I've just picked out, I was hoping to show you some other data graphs, but the ground truth data in Australia, we are very fortunate. We do have censuses, and they're every 5 years. But we don't have income for every one of those 5 years. So what we're looking at the moment is 96, 2001, 2006, 2011, 2016. 2020 is, 21 is being analysed at the moment and is just being released piece by piece. However, we don't have income for 96. We don't have income for 2001. You know, we've got other metrics, and I'll tell you what they are in a minute. So, you know, it's good, but it's never perfect, okay? So that's a good challenge, but ORAN is able to give a direct line to that, as they were to get a direct line to the WDPA or to the protected area data. Remote sense data for today, thank you to Ali. I am going to present some graphs of that. Again, as we say, just because I have the graphs and I was trying to replicate them using the census data, but it wasn't working in time. So I'll just present that today to give you an idea. You've already seen some graphs now, so it's not a big deal, but that was great. And Ali's been running the satellite image data through the mainframe, I used to call it mainframe, in France. So it's pretty neat, from Brazil. Okay, so here's the night lights for the moment. Here is a classic example, time series, 1996, and I've put arrows for when the intervention has occurred for the particular town. So each of these towns within each ecoregion is next to a protected area that was created at a different date, wasn't it? There's another source of variation. Then the protected areas, they're not all next to the same protected area. These are big ecoregions. They're as big as the Pantanal, okay? There are about 50 protected areas in there, and there are some towns. And so these arrows here, this one is next to Nuremberg, this is next to Manangrida, and this one here is next to Nulkor because it was created in 2012. So they're the protected areas there. So that's the sort of thing we have to make sense of. Is this robust? Does it indicate anything? How do we analyse this in a way to make sense? You'll note that these particular ones are Indigenous towns in Indigenous communities. They're Indigenous lands. So they're very different from this, which is a classic Western Australian corner ex-forestry area. Tall forests of the world, Jarrah forests. Two towns that have been affected by the closure of the forest industry. How much does that matter? How much influence does it have? So here, these protected areas, wahoo, they were declared after the timber getters got out and lost their jobs. So you've got these questions coming up all the time, and how do we deal with these? But within one country, so they're different. And Southeast Australia is very interesting, lots of sites there, so not too bad, but also lots of varying creations of protected areas. So we're going to present this as a challenge for statistics, etc. The census source variables are interesting because the ORAN group assemble the census data and other information rather well into these different blocks, and Janeth would know about this sort of thing, these sorts of levels of aggregation. States and territories are at the top, Queensland, Victoria, New South Wales. You might remember we've got about 5 of them in the country. But then we move down to little tiny mesh blocks, which are basically we don't access because ourselves because they're privacy controlled, okay? Because they've got people's names and streets and house numbers and things like that. Whereas we're working at this level, we expect. So this is the level we're talking about. And we've got 57,523 of these in 2016. This one we have only 2,310. So they vary depending on use. And here is a bit of a breakdown of the sorts of frequencies of these things. And, these are local government areas here, which are, they do bring in some of these other interesting names, which are historical, that do map. But this is a local government area, which is very similar to what we've been working on in Val de Ribera at various levels. Okay, and this is what the map of SA2 looks like in the country. So you can see why this is where the Manangrida is. They're up here, that little group up there. And this is where the confusion comes because the ecoregions have another map. And so we're overlaying social maps with ecoregions. So that's a bit of a worry for comparative, just to make, for language more than anything else. Okay, and these are some of the metrics. So you've heard about DHS. We certainly, so I've given you some plots of nightlights, But we do have longevity, same as for the Brazilian tree. We do have income, but not for every year. We certainly don't, we've given up on longevity. It's too inconsistent, too many gaps in the SA1s or SA2s. But Australia has been very keen on this one, relative socioeconomic disadvantage, and that has been consistently collected. Is it a good metric? Well, it's been well used. There are lots of benchmarks for its use, so it's not too bad. And we have the equations and lots of explanation. And this one, the Index of Education and Occupation. So having discussions with the US team, we think that this is actually one of the ones that will be useful, and it makes sense to us, hence its popularity in Australia. And this one, of course, does as well, because we've got a large Indigenous community that's not as well educated and moving into their own communities increasingly, and so this has been fairly well monitored and watched. So they're the sorts of indices that we'll play with. Are these mappable to other countries? Maybe to the USA, maybe not to France, you know, maybe not in the same way to East Africa. So how do we deal with this international, transnational comparison and work? Well, I always thought we'd have regional ideas. So with typologies, maybe of type. So maybe I'll be vindicated, maybe not. And that's about it. So thank you very much. And do note that we now have Southern Oregon University. So for all those people who want to download the PowerPoint from our Google Drive, it now has Southern Oregon University, which somehow got slipped off, which is good. I don't know. I never saw it. I had to battle to get Erinaha and EOSC Life on, and that was a few emails from Rona, but which is the European. Anyway, there we go. So thank you very much. I suppose my talk is not very final. We'll have more in a little while from me, so you'll have quite enough. But it might give you the idea that we're really battling through some of these questions at the moment. And when we ask you for ideas, we've already got some ideas from you. So, you know, and some suggestions, some of which we could follow up, some of which we could say, oh, we're spread too thin. But we'll see how we go. There we go. Oh, yes. Okay.
Green.
We've got to move on. No, battery's gone. No. Oh, yes. Okay. Yep.
All right, there you go. Okay, so I'm going to start by apologizing for the naivety of my question, but I'm going to ask it anyways because I'm in an audience full of people who know more than me. So when you're talking about the different variables, and you laid out lots of different sort of socioeconomic variables in the census data that's collected, and I've heard a lot about different census data and all these pieces that are collected. I had a conversation about a year ago, and I'm sorry, I realize I'm talking too fast, with a demographer, and we were talking about some of the challenges associated with the variation in the methods that this demographic data is collected between different countries. And I guess my question to you, but maybe even to members of the audience who've also said some of these words out loud, is there international organizations who standardize this together? Like, and if there is there, are these the kinds of conversations that are brought to these tables? Because I think as we move forward into some of the really tough conversations around global environmental change, you can't compare apples and oranges. And if you're not looking at the same granularity of data on a lot of different things, and in the context that I was talking about was migration, and we were thinking about demographic data on women and children and you know, all sorts of stuff that is sort of collected sometimes unevenly. Yeah, so I guess my question is, does this organization exist? And as part of these kinds of conversations, when you're creating these really cool projects in international fora, does someone show up at those meetings and be like, listen, guys, this is what we need from you? And if not, why?
So can I say, are you going to say something about this in the talk the next but one? Great. Hold your horses, Nicole. We're short of time. Excellent, excellent preempt for the talk after Jamie's. Very good. We know with the WDPA we've been looking at that. And yes, there is a group in PARSEC that is also looking at this. So yeah, it's a real question. It's a very big question.
They didn't plant me. I swear it's a real question.
Any other questions that we can put off for another speaker? Just wondering. Anyone? No? No? Sure? Oh, come on. Right, okay.
Yes.
So our next speaker is Jamie Trammell.
Hope so.
Jamie's the Associate Professor of Environmental Science at the Southern Oregon University. Oh, the logo just left. Jamie's the country lead for PARSEC Synthesis Science Strand within the United States. He's a landscape ecologist specializing in the integration of socioeconomic and biophysical drivers of hydrologic and landscape change. His core focus has been on alternative landscape futures using scenario analysis to explore integrated landscape change under different assumptions of uncertainty. He's worked in Australia, Alaska, and throughout the Western US. Welcome, Jamie.
Thanks. You're hired, for sure. Give all the introductions from now on, because it makes me sound way more interesting than I am. Awesome. Yeah, thanks very much for the question, Nicole. I'm not going to speak to it directly right now, but my students and we have delved into this question an awful lot. And so it's actually the impetus for a paper that we're writing right now, and they're going to talk about it in just a moment. So yeah, thanks everyone for holding out. It is 4:30 on the second day of a workshop. You're tired, I guarantee it, right? So I'm going to do my best to kind of keep this entertaining and brief, because nobody else has done that. I'm looking at you. No, I'm kidding. So in the US, you've heard sort of how we've now diverged into various pathways to kind of help still answer this core question of what are the impacts of protected areas on communities. And so in the US, we went round and round as a PARSEC community. We went round and round. How do we do this? Do we keep the same goals? Do we not? And so within the US, we said, okay, well, we need to specify some explicit hypotheses as to how protected areas may impact or impact communities, or how communities may be impacted by protected areas. And so we have three explicit hypotheses. There's going to be a positive impact because of ecotourism, a negative impact because of loss of access to resources, or gentrification, which I don't know if that's a term that translates well, but that's basically when you've got a lower income community that slowly transitions into a higher income, thus pushing out typically more diverse communities. And so we expect these three kind of phenomena to exist in the United States. We also have some ecological ones that are not necessarily tied to PARSEC per se, but we've got a couple of landscape ecologists on the team, and we can't help but think, well, if there's a major disaster or some sort of ecological event that happens within a protected area, that's going to trickle through and have an impact like we've seen in Japan on the communities, right? So it's not that the fact that it was an established protected area that had this drop in economic value, it's because of this loss of ecosystem. So those are our hypotheses. And so we first kind of just wanted to go in and explore what relationships exist, do a little bit of just descriptive kind of stuff, really, because protected areas in the United States, it's different from every single country. This is something that we're really getting into and helping to describe, and there's more sessions on this in the future. But we invented protected areas. I mean, literally, we invented the concept in the United States in the 1860s. There are no satellite images for before our protected areas. And so we had to kind of go through and think, okay, so what is the impact of protected area? I mean, really, they've been here longer than some of the communities. Some communities have existed simply because of the establishment of protected area. So let's just look. Well, let's just explore this, and within one state, figure out how to differ spatially, and then see if we can find some relationships. Also complicating everything is that we've established protected areas very much like Australia has established protected areas, and perhaps even how Brazil is now too. It's in places where people can't do other things, right? And so that means most of our protected areas are in the North American deserts, either cold or hot deserts. Places where we can't, it's not attractive to build houses or have agriculture or do forestry. And so there's this overwhelming bias automatically in terms of looking at protected areas as a proportional relationship to the ecoregions and to the people. So we expect different results because protected areas are in different geographic areas. This has led us to thinking, okay, well, is there some information in the socioeconomics that would help us sort of qualify the conditions, socioeconomic conditions near these protected areas within an ecoregional sense? So based on a literature review that you're going to hear about in just a moment, we looked to the US Census data. I'm really happy, we didn't coordinate this at all. Allison and Jeanette, all talking about the various levels of census data available, right? And in the US, we have census tracts, but those aren't largely available, especially not for every single variable that we're interested in measuring. Thus, we have this complicated hierarchy of, oh, some data is available this year and some data is not available these years. We only do our census every 10 years, but we have this American Community Survey that allows us to statistically explore or regress against these things in hopes that they're kind of close, but it's not perfect, right? And it doesn't include all of the economic variables we're interested in. But this is what we kind of focused in on: median income, poverty levels, educational attainment, total population, Gini index. I was really thankful for that question earlier. And then resource-intensive employment, which actually gets at our explicit hypotheses, right? We want to understand if people's economic potential is tied directly to the landscape. We want to be able to conceptualize this in a meaningful framework. And so we tested this out in Oregon, and we're still testing it out in Oregon. We've got some really good ideas, but some limited bandwidth to actually run these things. And Oregon is in the western US, and it's incredibly ecologically diverse, therefore socially diverse. Honestly, right, we've responded very well to the diverse ecosystems, and we've got like 1,000 different protected areas just in the state of Oregon alone, right? So we have a tremendous amount to consider. This is what it kind of looks like. Oh, bummer, it kind of got truncated, but total population. If you look at the state population versus population around protected areas, pretty much the same, just a little bit more variation. So we have extremely high populated areas and extremely low populated areas. That's interesting, something worth to note. Same with recreation jobs. We see a little bit more near protected areas than we do kind of statewide average. So that's good. We have some leaning to thinking, okay, yeah, maybe our hypotheses are relevant and useful, and this data will support it. We put together some tables just looking at sort of the breakdown. We also have different levels of governance associated with our protected areas, much like every other country does. And that actually has some really strong implications on the potential linkage then to communities, right? If we're talking federal, the money is coming from outside of the state to support that federally supported protected area versus state, that money is generally derived within the state. And so we can expect the income potential to be spread out then differently based on if it's federal or state. And we actually see this. We see state income or median income near state, which is the blue, managed protected areas being higher than the federally managed protected areas. It's interesting. We also see this with population. So the state and local kind of protected areas tend to have a lot more people nearby them. And so these are important qualifiers, right? These are splits or potential strata for thinking about the impacts of protected areas on these communities, because it's not all the same, right? So does it spatially vary? That's our second hypothesis. So we kind of explored these relationships. We're like, yep, there's something there. Does it vary spatially? Yes. That's percent of poverty, so that's percent of population below the federally defined poverty level, and that's how the U.S. has sort of fixed that inconsistency or like moving baseline, right? So we treat it as a proportional amount of people under an income level that would support a standard living kind of situation in the U.S. Varies tremendously, and everything in the dark green and the light green represents a protected area. And so you can see automatically, right, there's tremendous variation in something as simple as percent of people under poverty. You can also see the mismatch between how we do census boundaries and ecological land units, right? So that's actually what we tried to fix. we're tired of these hard boundaries existing and ecoregions existing in these two totally different spaces, even though they're in the same space, right? They're just the way that we draw things. And so working with Jeff Evans, my co-writer, co-presenter here, although I think hopefully he's tuning in, we kind of dreamt up this idea of, yes, we really want to do justice in looking at the effects of protected areas on communities, but we have to have a better sampling unit. We have to really think strategically about how do we expect these communities to relate to protected areas. And so this is when we started bringing in the census data and coming up with some sort of unified approach to bring economic and biophysical variables together. He's proposed this unified manifold approximation and projection, which most of you understand better than I do, because this is in your realm and not really in mine. Thank goodness it's in Jeff's realm, because he can do this magic and I help interpret then. So it's a machine learning algorithm, right? And it's a way of collapsing the variation, but across all those variables, and so it's ecoregional and socioeconomic, collapsing those in a meaningful way that honors this, it keeps the spatial relationships, which is key for understanding ecoregional kind of embedded socioeconomics. And so that's what we've been doing, and we've been mapping it back to space, and we have some preliminary results. So this is kind of what it looks like just in the initial run of the clusters. Size certainly relates to the strength of relationship, but and it doesn't reproduce very well on this projector, I apologize. You can kind of see these faint regions that give us confidence that, yeah, I mean, generally, there are some unique clusters that can be identified in this non-dimensional space. So cool. We kind of map that then to the various ecoregions and be like, well, this isn't as clean as we'd like. Let's look at it in space. That's really not clean. That's really confusing, right? So now we're talking about all kinds of different colors that we're kind of trying to fuse together and really, I don't know, you guys remember those Magic Eye posters where you kind of have to like relax and kind of, yeah, don't look directly at the picture and try to imagine shapes that would emerge. This is kind of in the step that we're in, right? We've got these clusters that have good statistical confidence that like 10 describe sufficient differences in across all these variables. When we map it back in space, it's a little more complicated. And what we're going to do with this now is it's still highlighting those artificial political boundaries, right? Those census boundaries. And so actually our next step is to create a hexagon fishnet layer that we feed data into that. And so it gets rid of all these artificial boundaries. We create another one, hexagons. But what we're hoping is that will allow the ecoregional data to be embedded a little bit deeper or a little bit more honestly within the socioeconomic data. But we have some really good evidence in the partial dependence plots that like these clusters are working very well to separate out sort of, things like, you can't read that. I can't read that. Percent of people in the communities who have completed high school. So this is not just we're not just looking at the raw data for like 2010, 2020. We're actually looking at the delta, the fact that we can't go pre-protected areas with images and everything. And so yeah, we're really excited. We're expanding this out to the Pacific Northwest, and hopefully we'll have a paper out there soon on this. With that, I'm going to say I'm done.
Questions for Jamie?
No, yep. Your question will come up very, very soon. Yes.
Okay, stupor from the carbs you ate a little bit ago, you're barely managing and you're still excited, but it's really hard to formulate a question. You'll think about it tonight, submit it tomorrow. Okay, gotcha. All right.
I will say briefly to Nicole's question about compatibility. We are hoping that something like this, and we've been talking with Pedro and Katya and everything, something like this is a good way to sort of neutralize, because variables are selected based on the ecoregions and the importance in this clustering algorithm. And once you have a cluster, a biophysical and socioeconomic cluster that you're sampling within, it sort of allows you to cast away some of those inconsistencies because it's now a new multidimensional space. We're hoping. We're hoping. We'd love to test this out in Brazil.
Oh, boy. All right, so Jamie, hang on. We're going to confer out loud with everybody. So we have 15 minutes left in the day, but we have an hour's worth of material. How do you feel about that? Most importantly, this is like the juicy bits. Okay. Honest. Internet still off? Do we care?
Maybe not as long as we get this.
Okay. Can you hang in there for an hour? Oh, one hand. Okay. Some folks are, okay, we have folks fiddling out. All right. What would be an alternative option? Can we front load tomorrow with some of our talks?
Tomorrow we've got the data study.
We can make time. Although I think the DDOMP still has to go first.
Yes. Oh, no, that's okay. Yeah. We've got cloud infrastructure with AWS. We've got we can probably move the data set compatibility. I think that would be good tomorrow. Is that okay? Because of both of them, I don't know. No, it's okay. And then reproducibility of deep learning experiments, which we had today. So they're quite long. AWS. We'll have to have them, I suppose. The only thing I can think of is that data compatibility work could be at morning tea tomorrow. No, that's too hard.
All right.
Say morning tea. Well, 2 lots of tea. Well, you've got 20. You tea and you tea.
Well, but in order to answer the question that's hanging in the air, should we do no? No? No. I heard no. Okay, I heard no. We're going to go with that because when a postdoc says no, you go with the no. Something I learned. All right. We will work out tomorrow's schedule to fit everything in. So thank you all for coming for day 2. I appreciate all of your, are there any additional, now that you've had a moment to reflect, are there any additional questions for Jamie?
Actually, sorry, tomorrow we do have some time in the afternoon. So, sorry, we do have some time. So if it's okay, my apologies. We have a session after 3 p.m. tomorrow afternoon. We'll just move this session now to that. Okay?
Perfect.
Perfect, and we'll be finished by 5. So that's really good. So, yes. So people remotely here, if you have a look at the schedule, it's due to finish tomorrow at 3 p.m. Brief 15-minute break, and we'll roll straight into Pedro, the data of the socioeconomic data, which we are all hanging out for, and the World Database. It's actually about big aggregated international data sets and standardized data sets, and then the further work by the 2 postdocs, which will be very good. And that will finish out the day very nicely. So look forward to seeing you tomorrow. Now, tomorrow we do have a fantastic day, so we didn't want to disrupt it, which is a hands-on day. So do come. We have got exercises. We've got remarkable people. Here we are, hands-on and training. We have, first up, how to prepare a DDOMP, the famous DDOMP, with Shelley Stahl, data and digital objects. So, you know, those museum objects and images and bits of rock, as well as then processes and pathways to disseminate science. So a science communication session with a Twitter game. So, yes. The spectrum of, I don't know that this is the latest one. It's not in quite the order. We've got controlled vocabularies and the spectrum of data repositories with some, I won't say with some. Then we've got DataCite and ORCID with Anna Heredia with some really neat ORCID exercises. So each of you will have an ORCID and join the cloud. Sorry? Yeah. Yes, we're going to create ORCIDs, so Yep. Beautiful, you know, cymbidiums and dendrobiums and things like that, for those of you who know cattleya's. Introduction to Open Science Organisation. So you're going to go to the world of the Research Data Alliance, which is an amazing world, and it is a remote world. So you can join the team globally, which is really interesting, and the Environmental Science ESIP group. And then we have something else, but I've lost the page. Yes, we have one more. It's just the page isn't there.
Yeah, thank you. Tomorrow we also will having the hands-on, which is almost at the end of the session. Yeah, but we have sending the guidelines, requirements for installing Jupyter notebooks, create an account Google Earth Engine API, and set up the configuration from notebooks. So we sent already an email with these requirements. Thanks.
Brilliant. So you've got to come tomorrow, and then at 3 o'clock we learn all about the Amazon Web Services and all these other things. Making sure the world is honest when it says, yes, we have 30% of our native vegetation protected. Yay! Which of course is all standardized through the World Database for Protected Areas. Is it true? Is it not? Okay. Thank you very much, everybody. Thank you, Pedro.